Hello, everybody, and thank you so much for joining our workshop. We are just going to give it a few extra minutes to allow additional attendees to join the room, and then we will jump right into content. Thank you so much. Hello, everyone. If you are just joining us, welcome. We are thrilled to have you joining us for this workshop, Databricks and Google Better Together. I'm going to run through a couple of housekeeping items before we jump into content. Drew, if you don't mind advancing the slide.
Sure. And there you go.
Perfect. Thank you so much. You will see the Q&A feature at the bottom of your Zoom. Please use that to ask any questions that you have throughout the session. We will do our best to get to all of those questions, and if not, we will get a list of those questions and can answer them post-workshop. The session will be recorded and the slides will be sent along with that recording in the next coming days, and you'll have a chance to engage with the lab post-session as well with that recording and slideware. So if you get stuck or pause, or if you need to or prefer to operate the lab on your own time and simply follow along today, that is absolutely all right. Next slide, please.
Oops.
Thank you. You'll see the lab access information here, and we'll post this in the chat as well so that you're able to copy and paste. No need to screenshot. And just a couple of best practices. Incognito does tend to work best. So if you have technical challenges, feel free to go into incognito. And then again, if you have any access issues, feel free to enable pop-ups and cookies. We do recommend operating the lab on Chrome or Firefox. Safari does tend to have more of those delays. And as always, feel free to ask any questions that you have to our subject matter experts in the Q&A chat. Next slide, please. Again, we will be posting this as well in the chat, but we want to make sure that you have deployment instructions. I often recommend just taking a quick screenshot of this slide so that you can reference it if necessary later on. And again, I'll post it in the chat several times throughout the session. And just a heads up, you will see my Zoom tile disappear around 9:30, and my colleague Jocelyn will be taking on my role. And I am going to transition now to introduce our fantastic team here, Drew, Alexander, Mohan, and Zachary. Drew is going to walk through the keynote, and the other three folks are going to run our hands-on labs. So without further ado, Drew, I'll pass it to you and pop up the welcome poll. Thank you so much.
Cheers, Sophia, and thank you for that. And hello, everyone. By introduction, my name's Drew Hurd. I've been at Databricks 5 years now. I'm the general manager of our Databricks on Google business. Fundamentally, what that means is everything related to Databricks on Google, be it product, go-to-market, or even revenue numbers, kind of all rolls up to me. So I'm looking forward to talking to you all today, a little bit about who Databricks is, our Google partnership, but then also giving you an opportunity to sort of play with Databricks on Google yourself with these great essays we've got accompanying me on the call. So just to kind of kick things off, I'm going to talk a little bit about Databricks, what Databricks is all about, then we'll weave into that the Google partnership. So Just at the highest level, I suspect most of you know who Databricks is. We've been around about 15 years. Originally, our founders were the original creators of Spark, started with a managed Spark environment, and then over 10 years, mainly through an awful lot of investment in R&D, some acquisition, we've now got to a point where we've got an entire data and AI platform. We're now over 12,000 customers. We just passed 4 billion in revenue. We've got about 15 billion of investment right now, and you probably see Ali on CNBC very often now talking about where Databricks is going and where the AI marketplace is going, because that's where we're very much focused today. In terms of our Google business, which is what I run, Databricks was originally started on AWS. 2017, we moved to Azure. In 2020, we signed our agreement with Google. We started developing Databricks on Google in 2020, and we launched in 2021. Now, just interesting for all of you, the thing about Databricks is, when our founders created Spark, they learned from that Hadoop world that the goal was to make Spark easy. So it was very much a managed service environment around Spark. So in terms of building Databricks on Google, you couldn't really just lift it off Azure, drop it on Google, and be ready in a month. You've got an awful lot of engineering work is done between Databricks and Google to ensure Databricks is highly integrated into that Google ecosystem. So it took about 12 months to do that original work. We launched in May of 2021, and I'm actually glad to announce as of January of last year, we now have 100% product parity. What I mean by product parity is it is a strategic imperative of Databricks to have a single platform across all clouds. So what we want people to do is have that identical experience and that identical product across all cloud, because really what we want to give our customers is optionality on cloud. So we're now at a point where we've done that. All the service list capability was launched last year. All our Gen AI capability was launched in January. So we're actually now there. Now, the interesting thing about our partnership with Google is you'll see sort of we've been Partner of the Year in 2024 and 2025 when it comes to the analytics world. But from an engineering perspective, Google's actually very similar to us. We're very much supporters of the open source world. We're very supportive of, how do we share our environment with other people? So from an engineering standpoint, there is very close collaboration between Databricks and Google. And there's a lot of really interesting stuff we're now doing in terms of integration between Unity Catalog and GCP and how we can take it to that next level of integration. Other thing I'll talk a little bit about later is just sort of our SAP and Gemini partnerships that we launched last year and what we're doing with Google in terms of that regard. Okay. So diving into a little bit about sort of how Databricks views the world and how it's looking at the world now compared to sort of, 10, 15 years ago when we started. Talking to our customers, what we actually hear is we hear three things when we talk to leaders of all our customers. One, they want to reduce TCO. So everyone's looking for cost reduction. Number two, they're worried about getting good data and their data is secure and they can make it available to everyone. And then the last thing on every board and everyone's executive is how do we do transformational AI? They're seeing what's going on in the AI world and they want that done immediately. So this is kind of the, what all our customers are asking for. And when I mean all our customers, we mean literally everyone, because everyone wants to be a data and AI company now. So whether you're a drug company, whether you're a bank like ABN AMRO, whether you're Rolls-Royce producing engines, whether you're Burberry, whether you're 7-Eleven, everyone is now becoming a data and AI company. And you guys who are on this call or practitioners, those things I mentioned at the beginning, low TCO, access to data, AI, you guys are the ones that are under pressure to actually make that into reality. And I'm sure what you guys are seeing is everyone kind of wants to do this, but it's a lot harder to do than people think. And if you think about why it's harder, and I probably don't need to tell you guys that, the first one we're seeing is just the data state is so complex today. So whether it's BI, orchestration, data lakes, data warehouses, streaming things, companies have all these different architectures and all these different proprietary formats, and all these formats create a massive premium on cost, right? And the world of Gen AI is making this even more complicated. So this fragmented data state is making it very difficult to sort of drive down costs. Second thing we're observing in the marketplace is that governance thing. everyone's talking about governance. And, it's related to regulation, it's related to data privacy, and then how do I protect my data from cyber attacks? And when we talk about governance, it's just not about your data. It's the governance of your models, it's governance of your tables, your dashboards, your reports, all your connectors. How do you do holistic governance across that entire data state? And then the last thing we're observing out in the marketplace, to that third point of how do we get AI, get the benefits of AI? Everyone's doing a lot of experimenting on AI, but very little of it's gone into production. So, the third thing we're focused on trying to help people is how do we actually get things into production, okay, with our customers. So what's the answer to all this, or how does Databricks view the answer to all this? It's our data intelligence platform. So what is a data intelligence platform? First thing a data intelligence platform is single copy of the data. So all of your data is stored in low-cost storage. In Google, it'd be in the GCS world, and it's in an open format. And the reason you want it in an open format is you want optionality on that data. You want optionality to do different things about it. So store your data in a low-cost format. Number two, put a catalog over that data. You need structure on that data. You need governance on that data. How do you manage that data? How do you know where your data is? How do you handle permissions, et cetera, et cetera? Three, you add knowledge to that data. And this is now what we can do with AI. So inside of Databricks, we've got things like Genie, which allows you to do intelligent things and use AI on that data. How do I build a pipeline? How can I use sort of just text to actually do things for me? And then the last thing is all the business users. So whether it's your BI users, your data engineers, whether it's your data analysts or it's your AI engineers, they're all working on that data set. And that's kind of what the data intelligence platform is. Now, just building on that a little bit, this owning your data thing is really key, and having your data in an open format. Like we 2 years ago, sort of, there was Iceberg, there was Delta, a few people were talking about Hootie over here. Like the reality is the data format wars are kind of over. Like it is kind of, it's in Delta, Iceberg, but all of them are just Parquet formats, right? But you really need to think about your data is how do I put my data into that open format and store that into low-cost storage to give me optionality. The days of proprietary data formats should be over. Number two, and one of the things that these guys will show you today that we're talking about is the world of Lakeflow. Lakeflow is something new inside of Databricks where we've actually we're re-looking at that ETL process. It used to be very expensive to ingest your data, transform your data, load your data. With Lakeflow, between our ability to connect to data sources, our ability to actually build smart pipelines now and then orchestrate jobs. With Lakeflow, we can make that sort of management of your data that much easier, or access to your data that much easier. And then the last thing on top of that is sort of your catalog control, right? Now, the interesting thing that we do with Unity that's quite unique is traditional catalogs are very much focused on, where is my data, who has access to my data, and maybe some access control over that data. What it doesn't do is manage those AI models, doesn't manage your file stores, doesn't manage your notebooks, doesn't manage your dashboards. Unity Catalog is a catalog that manages that entire data estate. And again, all your data in that open format. Okay. So this is kind of the data intelligence platform. And this is what we're going to show you today and allow you to spend your time working through. And I look forward to sort of your questions. Okay, now let's dive back into Google a little bit more in our partnership with Google. So the first thing about Google, Databricks talks about a lake house. Well, if you base it on sort of Forrester and Gartner on where is the best place to actually have your lake house, everything actually points to Google. So if you think about the Forrester wave of lakehouse, who are the leaders up here? It's Databricks on Google. If you look at data science machine learning platforms, who are the leaders up here? It's Databricks on Google. So just from a technology perspective and sort of a platform perspective, Google's a pretty good place to have your lakehouse, and it's a pretty good cloud for this sort of stuff. So what have we built on Google? As we said, we've taken that entire data intelligence platform and we've dropped it onto Google. As I said at the beginning, in terms of that engineering work, it's highly, highly integrated into that Google ecosystem. So, like I said, everything's stored in Google Cloud Storage. Everything leverages Google Cloud engines. Everything leverages Google Cloud Identity from a security standpoint. From a marketplace standpoint, everything goes through the Google Marketplace. So if you've got an enterprise agreement with Google, you can burn that enterprise agreement down with Databricks. So highly integrated into that Google ecosystem, right? And it's funny. I get into a lot of conversations with people of, should I use Databricks or should I use Google? If you're choosing Databricks on Google, you are choosing Google. Because Databricks on Google, everything is integrated into that Google ecosystem. From an analytics platform standpoint, you could use Looker to actually push jobs down into Databricks. We have very close integration into BigQuery in terms of passing data back and forth. We're now doing smarter things on the integration front. Similarly with Vertex AI, I'll talk about Gemini in a bit. Closer and closer integration, we've got direct connectors to Google Cloud Pub Sub. So when you think about using Databricks on Google, back to that point, it is part of the Google ecosystem. Now, the next thing, in my world, people often ask me, okay, I understand Databricks on Google, I understand cloud parity. How are people using Databricks on Google? Tell me the use cases. And it really comes down to two main use cases or two main things, and then a couple more we're seeing in the future. First one is multi-cloud Databricks. As we said, it's a strategic imperative to Databricks to have a single platform across all clouds. We have that platform. What we have is very large customers that are doing one of two things. They've either decided that I'm moving to Google, so Google is my strategic cloud, so lift and shift Databricks over onto Google. No problem. We can do that relatively easily. The other one, and the more interesting one, is multi-cloud Databricks. People are now looking to say, I'm running Databricks on Azure, for example. Google's now my secondary cloud. How can I run Databricks across both clouds? How can I share work product? How can I use Delta Share to share data? How can I use UC to govern cross cloud? So an awful lot of the investment Databricks is doing is that multi-cloud world that we're moving into. So that's probably the number one place we see people using Databricks on Google. The other place we see, honestly, is those traditional Spark workloads. That chart up in the corner was a survey I did 12 months ago about our top 50 Google customers, and 87% of them actually had BigQuery and Databricks together. And the reality is, as much as we all want to get rid of these silos do exist still. And a lot of people still want to use BQ as a business serving layer, BQ as an EDW. But what they do know is those traditional data lake workloads of unstructured data, Spark data, ML, data science stuff, that sort of stuff is really Databricks' wheelhouse. And we can lower TCO and get things into production much faster. And then if we need to, push that data out to BigQuery as a business serving layer. Okay, so these are probably the one and two most biggest use cases for using Databricks on Google. Now, this year we announced two things which I think are going to change this a little bit more. Not change this, but we're going to see two or three more things. First, SAP for Databricks. For those of you who don't know, we announced a strategic partnership with SAP, which really is two components. One, SAP are now OEMing Databricks. So SAP's BDC, so their business data cloud, Databricks is now inside SAP. And if you buy Business Data Cloud, you can use Databricks inside of SAP Business Data Cloud. The other thing we've done is we now have zero cost and zero copy charge for Delta sharing to push data from SAP into Databricks. Okay, so an awful lot of engineering work's done to do those integrations. We all know that SAP data has sat in this proprietary format for so long. This is an opportunity for you to get that very valuable SAP data and combine it with the other things you're doing in the data estate world. This got launched on Google 2 weeks ago. So it's now GA on Google. It was originally GA on AWS. It's now GA on Google. It's not GA on Azure yet. Last thing actually we're talking to Google about, and I probably need to do a better job on putting more graphics on this slide, is what we're doing with Gemini. So at Data and AI Summit last year, we announced that Gemini was going to become a native model inside of Databricks. All the engineering work's been done. We expect within the next 2 to 3 weeks, it'll be available to all our customers. Fundamentally, what this is going to allow Databricks customers to do is get access to Gemini models and actually buy usage of Gemini models directly through Databricks. And you're going to be able to do that whether you're using Databricks on Google, Databricks on Azure, or Databricks on AWS. So from a partnership standpoint, I think we are the only OEM of Gemini out in the marketplace. I think Oracle might be doing something actually that I think about it, but this is just shows to the closeness of the engineering work being done between Databricks and Google. So, multi-cloud, traditional data lake workloads, SAP, and Gemini integration is what we see going down the line. Okay. So with that, just kind of the last thing from a GCP standpoint, why Databricks on GCP? Back to what you said, there's that seamless integration to Databricks on GCP, alignment on open source. We've done an awful lot of work with RSAs, with engineering to ensure it's optimized. And then Google itself actually very much says to the marketplace from a network and security standpoint, Google is the best cloud. So I will pause there and take any questions, or I'll look at the questions. And in the meantime, while I look through the questions in the chat, I will pass this over to Alexander, who will help you set up your environment and get you into the environment so you can start playing with it. Okay. So thank you for your time. Feel free to reach out to me directly if you got any questions after the session. Thanks, guys. Alexander, over to you.
All right. Hey, call me while I'm
Do
refilling
I
my
need to
coffee
release
cup.
my screen, I guess?
Yeah, that'd be
Go
great.
ahead and release the screen and pass to Alex.
Done.
Thank you.
All right. Can you hear me? Hello? Welcome? Yeah?
Yes, we can. Thank you.
Perfect. Love it. All right. Yeah, again, just to rehash, I think GCP is a great cloud, and the fact that Databricks finally has asset parity on it is great. When I was a practitioner, we were using GCP for some of our Databricks stuff, and it's awesome to see kind of where the partnership has gone. And I'm personally really excited to start using Gemini, even in some of our internal Databricks kind of workspaces. So great update there, Drew. All right, let's get moving and grooving here. So Sophia put a whole bunch of instructions on the right-hand chat pane. I'm going to walk you through those, so don't be too overwhelmed by them. And then we'll kind of dig into the actual code and demos. Boom, boom, boom. All right, let's get going. Sorry, Sophia, I'm minimizing your face. All right,
No worries.
cool. So the first thing we need to do is navigate to free edition. This link is in chat, but I will drop it in chat again. Boom. In free edition, this is a new version. It's a revamped version of Databricks Community Edition as well. So this is always free. You don't have to enter a credit card or anything. And probably about 90% of Databricks is ready out of the box, which is a huge improvement over where the old Community Edition used to be. If you don't have an account, you can just click sign up for free edition. Or if you already do have an account, you can click log in. It connects naturally with your Google account. So I have mine connected up to my Gmail. So for me, I can just connect with Google and sign in with my Databricks Demos Gmail account. So again, we'll give you a second to kind of log in here. The goal is once you connect this to your Gmail, it should auto spin up a workspace in the back. Databricks operates with this idea of workspaces, which is going to be directly connected to your cloud of choice. When you spin up a compute engine within Databricks, it's actually spinning up a compute engine on GCP, for example. So mine already has an account linked and a workspace linked, and all I'm going to do is click on that. Again, for most of y'all, it should just navigate you directly to the workspace, and you can see all of my fun code that I've been executing in here. Yours will be a lot more empty and blank. But yeah, you should see a welcome to Databricks as well as this home page. And you know you're in the right place where on the top left it says free edition underneath the Databricks logo. So I'm gonna give you a second to log in here, and I'm actually gonna grab my coffee that I was refilling when Drew kind of passed it over to me. And then we'll dive into just a quick navigation of the workspace as well as the installation of the code that we'll be running. So 2 secs.
Thanks so much, Alex. And for the folks that are getting their workspace loaded, Thank you so much for doing that. As a friendly reminder, we'll take natural pauses throughout all of the hands-on lab sessions. So feel free to take your time. And if you do get stuck, just make a note in the Q&A chat, Q&A feature. And if you prefer to follow along, we'll also send the slides and recording, and you'll have access to that lab environment post-event. Thanks.
Perfect. All right. So like I mentioned, the Databricks free edition, you do not need a credit card. It's all open, all free. And again, you can do most of the things you can do in the in the enterprise version of Databricks as well. The only thing that's locked down a little bit is you do not have access to create compute engines on free edition. We will be using Databricks serverless. So on the left-hand side there, I went down to compute on the left, and you can see the compute engines that are available to you. We have a serverless warehouse that we can execute SQL commands on, and we'll also have the general just serverless compute that Databricks can run to execute your Spark workloads as well. So you have some, we don't really want any of you on free edition to be spinning up giant GPU clusters, right? So we're just going to be assigning some compute there. And the next place we're going to go is the catalog. The catalog is going to be where your data is stored. Here you should be able to organize your information through catalog, schema, and table. You can kind of think of catalog as like your overarching database engine. Within your catalog or database, you have various schemas, and within your schemas, you will have tables. We will come back here in a second after we have installed our code. There's a few other options here on the left-hand tool pane that we'll come back to over the course of the workshop. Some things to call out are the SQL Editor and dashboards, where you can write your queries and generate your business intelligence dashboards. And then, of course, AI, ML. Again, this is where there's a little bit of lockdown on free edition. You don't have 100% of the large language model availability that we have in enterprise, but it should be enough to get you started. And if we have time, maybe we'll actually touch on some of that Gen AI capability later in the day. All right, so to install our code, let's navigate to our workspace. When I click on workspace, it should have actually opened up my own personal location. So as I mentioned, every single one of you should have your own unique workspace. So you should be the only user of that workspace. To navigate to this without the left-hand pane shortcut, if we open up our workspace, we can go into users, and I can again see that my Gmail is the only user of this workspace. And when I open up that user, this is where we're going to create that notebook that also is described in chat. So once we navigate to our workspace again, you'll probably see a couple things like the workspace usage dashboard and maybe a starter kind of Genie space. Again, we'll touch on that later. But what we need to do first is create a notebook. So with this big blue button in the top right, I'm going to click Create and then Notebook. And this is going to create a new notebook, a new Databricks notebook, where we can write and execute Spark code using PySpark, R, Scala, SQL, Python, whatever your favorite language is to do kind of data engineering and data science. Our notebook, if we look at the top here, has defaulted to being in Python, and we can change the name of the notebook by editing the text up here at the top. So I'm just going to call this test or install demo. Woo, exciting. One last thing we need to do on the notebook before we can start copying over that code that Sophia dropped in chat. We need to connect to that compute that I was describing earlier. You'll notice here at the top right, we have this blue flashing dot. And if I actually close my left bar here, it actually expands a little bit. And we can see that it's asking us to connect to a compute engine to run our code. If I click on this connect, the only option we have is serverless, which is fine for our workloads today. So again, behind the scenes, essentially Databricks has a bunch of compute power that we can allocate to your workspace, so you don't have to worry too much about actually setting up the compute specifications or the requirements. This will auto scale everything as needed. as well as just provide a less infrastructure heavy way to kind of accelerate our ability to run and kind of generate these demos. All right, this is your obligatory pause. All that we've done, we've gone to workspace, we've gone to create notebook, we named the notebook, and we connected to our serverless compute. From here, this is where we're going to start copying over that code. Whoops, I posted that in the wrong chat. Here's the link to free edition in case you haven't seen it yet. And now we're going to start moving some of this code over. So the first cell that we mentioned in chat is this pip install -qq db demos. And I'll drop this into chat again. Hopefully. Cool and cool. So this is our first cell. All that we're going to be doing here is installing a Python package called Databricks Demos. Super original. This is actually located on GitHub. We'll drop these links into chat as well. Essentially, Databricks has a bunch of pre-packaged demos that you can utilize to explore the platform. And you'll see that all of these demos can actually go across many different verticals and industries, as well as use cases. So for me, typically I like the full tutorials. You can see that what runs on serverless, what doesn't. We're going to mention a little bit the Pandas API later today. If you want a deeper dive, you can go into our demos there. Same thing with data warehousing with primary and foreign keys, as well as more advanced dashboarding tutorials as well. So I'll actually, we'll have one of the TAs kind of drop these links into our chat, or I can drop them in after I kind of finish up my session here. But long story short, we want to install our, there it is. We're going to install Databricks demos, and then once we've installed this library, we're going to specifically install the churn customer 360 demo that we'll be going over in the next few hours. Cool. While that's going, I'm going to go ahead and grab the second cell here. Perfect. The second cell is going to be import DB demos and then list them all out. Cool. So my first cell has finished. We've installed DB demos, and now I can list all the demos that are available within my workspace or within this package. And you'll see we have the whole lakehouse paradigm. We could have some demos focused on engineering. We could have some focused on AI, BI, and we could even have some just focused on traditional data science, like image classifications and more advanced feature store work that, again, we'll touch on here in a little bit. The demo that we'll be using today is going to be the C360 reducing customer churn example, which will take us through everything from data ingestion, data transformation, model building, governance, and of course, dashboarding and reporting. To install that demo, we're going to grab the third line in our chat. So I'll say Databricks Assistant, not now, please. Boom. I'm going to add one last change here, which is just, again, y'all don't need to add anything here. This should just work. But I'm going to write overwrite equals true. And I'm only doing this because I've already installed the demo. So I want to delete it and reinstall it, which is hopefully what this line does. So if you do ever want to rerun this demo in your workspace, I recommend including the overwrite equals true parameter just to make sure that you delete any of the old the workspaces. Cool, so this should have worked. I can see that it installed a lot of things. It's giving us the information of all of the notebooks that were installed, as well as our pipelines, dashboards, and even some machine learning workflows. So before I pass it off to Zachary to cover some of the machine learning work first, let's just double check that this actually installed the things we wanted it to. On the left-hand tool pane here, we see a couple of different icons. The one I'm going to click on is this folder. This is essentially just going to operate as a file explorer or finder, right? It lists off all the files that we have. And if you click this folder icon, once you've run this command to install the demo, you should, fingers crossed, see another folder here called Lakehouse Retail C360. And again, this is inside of our user workspace. And wow, amazing. I love it when things actually load. So when I run this, it looks like I've seen all of these different subfolders that we're going to walk through over the next few hours, as well as our dashboards and things as well. So to get started, let's just click on the 00 churn introduction notebook. You can either click on it once or double click on it to open. It'll open up as a new tab within our notebook workspace. And we'll kind of read over on what we're trying to do here, and then we'll double check that the data is actually loaded as well. Or also, maybe I should check the data first, and then we'll read through what we're doing. Nah, we'll read through it first, and then I believe the data is working here. All right, so what is our project? What are we doing today? We're going to be looking at utilizing the Databricks Data Intelligence Platform for a specific example around retail and consumer goods. As Drew mentioned at the top, Databricks is recognized almost universally now as being one of the best enterprise data platforms. And what do we mean by data platform and not just data warehouse or data lakehouse or AI? Well, when we think of data platforming, we think of your entire data ecosystem. How do you get data from its raw source, maybe an API, a web page, a CSV, whatever? How do you bring that data into a centralized location where we can then connect it, clean it, and make it available to anybody that wants to use it, right? So that's going to be more of your traditional data warehousing. Except if it's unstructured data, right? If it's videos, if it's images, if it's unstructured or semi-structured text files, PDFs, or even JSON blobs. We want to have a single source of truth for bringing all of these different types of data into one place, cleaning it up and preparing it, and then, like I said, making it available for our analysts. However, the data ecosystem doesn't stop there, right? Once we've cleaned and prepared the data and made it available, we're going to have our machine learning engineers, our data scientists building traditional models off of this, your predictive regression models, your classification models, your random forests and XGBoosts, as I like to call them out, right? And we need to organize those models too. We don't just want our data scientists to be creating a random forest on their personal laptop and like calling it a day and hoping for the best. We want to make sure that these models are stored, are governed, and are transparently available to anyone that may want to consume those model predictions downstream. In addition to modeling, of course, we have our dashboarding and our new integrations with generative AI and large language models. We want to make sure that if we are using large language models or LLMs to interact with your data, they need to be governed, secure, and again, should be brought to your data. We shouldn't be bringing the data to the LLMs, especially if they're externally hosted. We should be bringing the LLMs to your data within your environment and ecosystem inside your governed stack. So we truly believe that Databricks is the best place to do all of this. Unify your data, unify your governance, and unify your intelligence all kind of in one place. But as Drew also mentioned, the Databricks is really good at interacting with other technologies and other systems. You can't expect any single business to have everything done and running in Databricks, no matter how much Sophia may want that. So we integrate really well with tools like BigQuery and other GCP stacks, PubSub, GCS, right? Vertex, all the latest and greatest through Google too. So what are we doing today with our churn data? What we want to do is, as our data engineer, we want to be building in and synchronizing data from disparate sources. Think your CRMs, your ERPs, your mobile apps. We want to bring all this data in, we want to clean it up, make sure that it's ready for analysis, and then we want to join it together to create reporting or gold level tables. Next, we want to make sure that we have proper governance on those tables. People can only see the rows that they need to see. We have PII masked, etc. Then our BI analyst is going to create dashboards around this data. Our data scientists are going to be creating machine learning models on this data. And finally, we could even then dive into using large language models to help us do text to SQL, query this data, and pull out insights at scale. AI-powered intervention. I love it. And we're going to demonstrate that the Databricks platform can really, truly unify everything across this ecosystem. All right, so that's kind of the overview here. We'll dive into each of these sections individually as we cover them, but let's go double check that our data actually loaded. So on the left-hand side here, I'm going to open up this catalog. I'm actually going to open it in a new tab. To open things in a new tab, I just right-click and then open link in new tab. And if we pop on over here, we should see under My Organization Workspace, we should hopefully see a new schema called DB Demos Retail C360. And again, this is where we told it to install. If you remember our test installation script, we told it to install all of these tables inside of our workspace catalog inside the DB Demos Retail schema. So hopefully we should then see a whole bunch of tables here. I'm seeing 10 tables. You may see a little bit less than that. And under volumes, you should see a folder here as well. So in this volumes, I'm seeing C360. All that a volume is a Google Cloud storage bucket that holds our data. So we'll come back and check this out a little bit later downstream, but I just definitely wanted to make sure that we should be able to see tables and volumes here. Finally, this should have kicked off a job. If I go to jobs and pipelines, yay, I do see that I have something running here. So if you should see both a pipeline and a job. If you click in a job, it's going to be showing some various tasks here. All these tasks are doing are just installing the data and making sure our workspace is available. So all that we're doing so far, we've loaded the data, we've started our pipeline, and we're initializing some things. And again, don't worry about this. We're going to cover all these codes and tasks and actually create this during the workshop today. But I did want to make sure that hopefully we have it running. And again, the only thing to maybe call out here is don't worry about the last task. For some of you, it may fail just because of some of the limitations with free edition. But give it about 10, 15 minutes and it'll run all the way through. But all that Zachary needs before I hand it off is this last task finished up, which again should be pretty quick here. So if you have data underneath your DB demo schema, again, what that looked like is if you have any tables and volumes and stuff here, you're in a really good shape. And in addition, if you go to jobs and you see the job actually having a little spinny circle next to it, that also means you're in a really, really good shape. Zachary, anything else before I pass it over to you? I think we should be good because by the time you're actually, yeah, there it goes. So mine actually just finished creating the feature store table. So you should be able to run any of your code as needed here as well.
Cool.
I'll
If there's
pass
nothing
it on
else,
over to you.
yeah, if there's nothing else, I'll take over here. Let me share my screen. We can get underway. So I'll be with you guys for I want to say probably about the next probably the next 45, 50, 60 minutes-ish. And we're going to be going through in particular 5 different notebooks in total. And the idea behind each of these is that what we're going to be leading with today after that setup is kind of the why. Why are you going ahead and doing all this work? To what end? What value can you actually create? Loading a bunch of tables is great, but at the end of the day, you're actually after some sort of goal. In this case, you're really after the goal of having a 360 view of customers in the context of churn calculations. And ultimately, the notebooks that we're going to be going through here are really oriented around taking the data that had just been loaded and that we're going to be talking more in depth about how to engineer and manage subsequently, and creating predictive models out of those that can get at those questions of churn. Before we get underway here, I wanted to mention a little bit about why using Databricks as a data science platform was so compelling for me personally. Prior to coming to Databricks, I had been a data scientist for 10 years. And as you increasingly get more enmeshed within the building of different machine learning models, you end up finding that management and generation of different models, housing those models, oversight of those models becomes increasingly complex as the ecosystems, as your ecosystem continues to grow. Databricks provides an all-in-one platform to manage the governance, manage the deployment, manage the training, manage your data, manage all aspects of it, a unified data intelligence platform. And so what we're going to be going through here is one small aspect of it, but I really want you to think about it as the capstone to so much of the other work that you'd be doing as part of the larger data intelligence platform. All of your work around governance, all of your work around maintaining and improving your data tables, that is really coming to fruition and bring a lot of value to you finally as a result of some of the things we're going to be talking about today. So as I mentioned, the process of being able to ingest and query your databases is going to be a first step, but you need to actually get value out of it, right? For a lot of the different marketing and communications that you're going to be seeing, that you see as individual consumers in your day-to-day lives, you notice how hyper-personalized they are. They know the prior products that you've purchased, and then therefore can figure out what products you're likely to purchase in the future, or how likely you are to stop purchasing these products altogether. That's what we ultimately mean by churn. And indeed, there's a lot of great research out there that shows that the companies that are most heavily invested in AI and ML are the ones that are then succeeding at being able to do that, to the point that being able to have these sort of client interactions, to the point that then 90% of enterprise applications are going to be AI augmented by 2025. And then in addition, there's just incredible amounts of business value being projected as a result of adoption of these systems as well. So I mentioned that machine learning is really going to be the capstone to a lot of the work that we've been doing so far, but it's going to be really challenging because the process of building a model, as I mentioned, isn't just training something and deploying something. There's a whole cycle of governance and a whole life cycle that really makes up the process of being able to successfully deploy a model and keep it in production and generate value off of it. So for example, I know Alexander earlier had mentioned some of the different personas that we might be able to think about who is going to be getting a lot of value out of this. In this case, we could talk about Mark, who has a variety of different responsibilities that are listed off here, each of which then corresponds to a specific step in the overall machine learning lifecycle. Ultimately, all of those things, those 6 steps, all of those are then being able to be done inside of the data intelligence platform. So one of the big things that we're going to be able to do here is, so the model that we're going to be creating today is going to be dealing with predicting and explaining customer churn. And one of the first things that we want to do is to be able to build out a feature set that then can be used to train our models. So the user table had been already enriched with churn data in some stages that we're going to see later on. But for right now, just accept that, keep it in your mind that we already have a table that has the requisite features inside of it and the requisite data that we need in order to make these sort of predictions. What you're going to do first, if everyone's following along here, sorry, just trying to keep track of the Q&A as well. If everyone's following along here, what you'd want to do is you'd want to execute this cell right here. So this cell is going to go ahead and install the Databricks SDK, a few other packages as well, and then restart Python as well. But these are just getting your hands on the requisite packages that are then going to be used subsequently. Additionally, cell 4 is just going to be resetting it's going to be running the initial setup to make certain that all of the different assets, all of the different variables are going to be in there. And then in addition, you may know that while I'm going to be walking you through code, walking you through the results, walking you through the significance of all of this, I'm not going to be running it live. For some of these cells in particular, they would take a little bit too long within the context of a demo to properly show off, for it to properly run and to keep me talking the whole time. Instead, I'll be showing you the results and showing you, telling you what the code does. So again, as part of the prior steps that Alexander had walked through, you should have access to a table that had been called churn features. So within the context of churn features, we can notice a few things really quickly, and I'm going to point them out to you. For one, we have a user ID, which we can assume is a unique identifier. And then after that, we have a variety of other We have a variety of other biographical or demographic information related to each of the different users. So we have age groups. We have the channels that people were funneling into our system on. A predicted value, a value related to whether or not they had churned. Country, so location, gender, how many orders they've done, the total spend, total count of items, which platform they're on, how many events and sessions there's been, when they first started being our client, and then how long it's been since their last activity or event. So that's the normal sort of really basic information that you would expect to have out of clients in order to be able to predict whether or not somebody will end up churning. What we're going to do now is we're going to use a package called Seaborn. So Seaborn is one of the packages inside of Python that's being used in order to perform visualizations within the context of data analysis and then eventually machine learning as well. It's capable of some really beautiful plots and really beautiful graphics, and that's why it's ultimately being used here. What we're doing is we're importing it, and then we're creating what's called a pair grid. And so the significance behind a pair grid is that we're going to be able to compare multiple different variables against each other in order to think about how they interact with each other. So, for example, you can then so in our case, I mentioned earlier that we had age group, total amount, and order count. Those are then being used here. And the idea is that you should be able to figure out, well, how does the distribution of one of my elements or one of my features interact with another feature? So you can get into visualization by doing that. Additionally, there are certain things that you can do as well that if you have a team of data scientists, they might be familiar with a really common Python package called pandas. Pandas, there's an implementation in Spark of pandas, and we can therefore use Spark in order to scale our pandas code. Typically, within the context of machine learning project, you'd also find a little bit more work being done around preparing data and preparing your data, basically, and more complex feature engineering, for example. We're keeping it simple for this demo, but just understand that in general, actual systems that get into production are oftentimes much more complex than this. So next up, what we're going to do is we're going to instantiate the Pandas API here, and we're going to go ahead and use Dataset Describe. And I mentioned earlier that there were a whole bunch of columns above. Within our case, we're going to be dropping those from it altogether. And then additionally, we're going to be dropping rows that have any missing values inside of it. So in this case, so there's a few different options of where you can go here. If you were just interested in getting a model into production really quickly and wanted to de-emphasize some of the governance or some of the oversight of the system, you would probably skip this next step. But the next cell really is dealing with feature storage. So the feature store is really there for being really there in order to get a better handle on the governance and maintenance of the underlying features that are being used to contribute to a model. There's a number of different advantages for this. For one, you can directly observe keep track of, and monitor the distribution of the features that you are going ahead and putting into that you're going ahead and using as part of the model. But more importantly, as a data science team tends to put more and more models into production, there's a higher and higher chance that a lot of the features that they would have used in a prior model are going to be used in a subsequent model as well. But keeping track of massive data sets is going to be really hard. So the feature store sort of addresses both the governance of the models going into, the features going into a particular model, and the features generally across multiple different models. So it aids in reusability, aids in governance, aids in surfacing and reusability of the underlying assets too. And then finally, the other thing to note is that, so it helps you to figure out which new features can be used in subsequent models, right? The other important thing is that it also, as part of the overall UI, you can then know which model is going to then be dependent on which set of features. You can think about this almost as lineage or traceability in that way. So you can actually figure out what things are being used in order to create which model, which is really helpful so that you don't have to go back to the code where you did all of your feature engineering. And so the upsides to using a feature store are then what's being instantiated here in cell number 11. So what we're going to do is we're going to import the feature store client, declare it here, and there's two different options here. So if it already exists, we're just going to drop it. But otherwise, we're going to be creating it from scratch. And so the feature stores are getting stored as a table, and we are calling it ultimately churn user. Sure. Sorry, from the attendee, just Q&A chat very quickly. I'm not actually running these in the moment. Some of the cells that we're going to get to later, especially around the final deployments, are so time intensive, so as to not lend themselves to a demo. So I preloaded a lot of the work already and ran it beforehand. So within the so the feature store is going to be getting stored as a table here, and we're going to be calling it churn user features. And the primary key, we're declaring it to be a user ID. We're using this schema right here. And then in addition, if we were just go ahead and create this on the description, it might be hard for somebody who comes after us to know what this is, what the significance of this is. And therefore we use the description as a open-ended description of what we're going to end up creating here. So in this case, these features are derived from the churn bronze table in the Lakehouse. We created dummy variables for the categorical columns, cleaned up their names, and added a Boolean flag for whether the customer churned or not. No aggregations were performed. And then ultimately, we would then want to write that to the table that we had just created. And then what we do is we read it out in order to view the table that we'd created. So I noted earlier that there were certain features that from this table up here that we had dropped. In particular, I believe there were certain features that had gotten dropped as part of this call. You'll see that those no longer appear here, for example. So in other words, it's working as intended. So let's talk a little bit about what we can do in order to speed up the overall process of model development and model deployment. So one of the major problems with getting models into production is that oftentimes they can get stuck in what I sort of think of as science fair land, wherein we're sort of doing a ton of experiments. A lot of these experiments are manual, and being able to actually get them into production is a much more extended process than what it could be otherwise. Databricks happens to leverage this open source project called MLflow that has a variety of different advantages to it. It helps you to track your models, helps you to ultimately deploy them, helps you to automate a lot of the processes around monitoring them. And then every time that your data science team would be working with one of these, Databricks is then going to help to track all the different hyperparameters that were used as part of the training process and then save it. So that then when you are going ahead and putting a model into production, you don't have to go ahead and guess what the parameters were that ultimately contributed to the creation of this model. MLflow is instead going to directly help to keep track of that. Additionally, the other thing is that, so you can sort of think about this as a glass box solution that lets the data science team work with superior observability, but without actually taking control from them. So in particular, we're going to be using AutoML with our churn data set. So if you wanted to go with a more UI-based approach to this, instead of a more code-based approach like we have here, you can actually go over to the experiments button right here and click through that, and you'd be able to see the experiments that are ultimately going to get created as part of this process. But in this demo, we're going to be sticking with the code. So what I'm doing here is I'm going ahead and declaring a path, and I'm also then giving it a name. And so because I'm not going to be ever creating two models with the same two experiments with the same name at the same time, this then is also going to be acting as a unique identifier. So what I'm going to be doing is I'm going to be I'm going to be importing AutoML, and I'm going to be creating a AutoML run, specifying the name and the path, and then reading the, oops, sorry, one moment here. Oh yes, Alexander's pasting great stuff in chat as well here. Um, what you can do is you can then go ahead and um, declare the AutoML. Uh, uh, you can declare the AutoML object. You would use the name and the path as we created earlier, and then use the churn user features that we had created above. I mentioned earlier that churn, it refers to whether or not an individual user had churned in the past. So that's ultimately what we're targeting here. And then we declare a timeout minutes of we declare that it will time out after 10 minutes. And then all users can then access the shared experiment. And then alternatively, there are exception handlings here in case that happens as well. So, alrighty. So before I move on here, okay, so before I move on here to the AutoML generated notebook, so before I move on to this, any questions in the chat or any questions in any questions in the QA?
What are the
So perhaps
benefits of using a feature store table versus just a regular Delta table?
that's a hard question to answer just because you'd keep me talking for the rest of the time. So the advantages over it are legion. So I mentioned earlier that feature stores are really useful for being able to keep track of observability, keep track of the individual features that are contributing to a model, and keep track of the overall governance of all of the elements that are then given rise to a model, right? But your question asked about a feature store versus something else?
No, I just meant like
Oh,
keeping
just
it as like
generally.
a regular table, yeah, within the catalog.
So I mean, if you were to do that, instead you would have to be much more, I guess that is an alternative approach. You would just have to be much, much, much more purposeful about maintaining that and declaring that and making certain that all of the information inside of there is being actively updated as part of every sort of run that you're declaring and going through. The advantage of explicitly using the feature store object and the feature store interface is that a lot of that manual work is abstracted away and handled automatically as well. Okay, so let me move on to the next notebook here. And so within within this notebook, one of the things that you would notice if you went to again, AutoML runs can take a while to run. Again, one of the reasons we're not doing it live here. But after an AutoML run, after an experiment has been run, there will be a number of different runs associated with it. And based on the UI, you can then go into each one and select which one is best based on whatever metrics you're using to think about what's best. And the idea then is every single run that has been created automatically generates a AutoML generated notebook that are going to be able to help you to bootstrap your ML project. Early on, when I was a data scientist, a lot of the systems that were claiming to automate a lot of the coding of machine learning projects away from data scientists had the downside of then not having any underlying code that you could then use as a starting point for further advancement. So a really good way to think about these runs is as a starting point for then being able to create a fully fleshed out model. And as we're going to see in the notebook here, this isn't just like a few lines of code here or there. It's a really quite extensive notebook of all of the individual steps that are contributing to the best model that had been created, and that then you can use as a jumping off point for even better and further development beyond that. So that's ultimately the mindset and the motivation that we have here. So as I mentioned, AutoML is going to be generating many different models to try and many different notebooks in order to generate the best model, right? And for this demo, let's just assume that this model of the different this notebook represents the results for the best model, right? What we're going to do is we're going to go ahead and install we're going to install the requisite packages here, do the setup as we had talked about in the past. And what we're going to be doing in this case is we're going to be using a light GBM model as part of this process. So again, one of the things, if you wanted to do, this is an auto-generated notebook. If you wanted to rerun it, it should be then the case that the final results that you're getting out of it are extremely similar to the results that are then displayed as part of the run of the AutoML process that you had kicked off. So what we're going to be doing is we're going to be getting the last experiment here. We're going to be keeping track of the experiments. And then what we're going to be doing is running the notebook with the data analysis to get the data from the artifact, and then getting the best ID from that as well. What we're going to do now is we're going to we're going to load the data. Again, this data should be extremely similar to the data that we just saw in the prior notebook related to the sorry, again, still trying to monitor chat there. This data should be extremely similar to the data that you got to see previously in the churn data set as well. And so a lot of the channels, the user IDs, the total amounts, churn, which is again the column that we're most interested in here, those are all getting preserved as part of this notebook. What we're going to be doing now is we're only going to be selecting columns that are supported. By supported, I mean able to be translated into a format that a machine learning model can understand. There are certain types of columns that might not be. For example, if they were extremely verbose, if it was a paragraph of text, there might be certain columns that aren't getting selected as part of that. Additionally, if you wanted to figure out why a certain column was dropped, you can go to the AutoML experiment pages to get an explanation for why these were dropped as well. So again, this is automatically generated code. What we're going to be doing now for the next several blocks is going through specific data types that are going in that we have selected and that can get used, and performing processing on them so that they can be used. So like namely, what we're going to be doing now is date time. Just to be really clear, last transaction, it's a date, but most machine learning models can't process a raw date by itself. Instead, we need to turn it into some sort of format it can understand. Same thing with other columns here, like words, for example. Those are categories, and we need to transform them in some sort of way. So the next several blocks of code that I'm going to be going through are all variations on that. They're all transforming the data in some sort of way in order to handle the specific data type we have in front of us. And the first one, as I mentioned, is going to be a date time processor. So there's a number of different ways in which you can represent dates. In this case, we want to be extracting information based on the Unix timestamp, whether or not the date is a holiday and whether or not the date is a weekend. And these two in particular might then correspond to how likely it is for somebody to buy something, which again is useful within the context of a consumer churn model, right? Additionally, there are other ways where you can extract information by getting out the hour of the day. And one of the interesting things about date times is that you actually need to encode them cyclically in order to note the fact that our years are a cycle, our weeks are a cycle, our days are a cycle. So without getting too far into the code, each of those different pieces of information are then being extracted out by some of these. So, for example, a one-hot encoder here is being invoked in the case where you want to be able to note whether or not something is a category, for example. You also have a timestamp transformer here for transforming it. So there's a number of different transformations going on here as well. Next up, there are Boolean columns. So Booleans are binary indicators. The handling here is a little bit more simple just because most machine learning models can understand a 0 or 1. So instead, what we're doing is mostly around being able to impute missing values and then converting those into ones and zeros. Next up, numerical columns. So if you have a whole bunch of numbers, again, that's a format that's already pretty interpretable by most machine learning models. But if you have the case wherein you have a value that is missing, what do you do with that? Well, in this case, the default code goes ahead and imputes it with the mean. So for every missing value in a particular column, what it does is it takes the mean of that and just imputes that value there. For categorical columns, there's a few different handlings here, a few different ways where you can handle categorical columns. In this case, what we're going to be doing is dealing with low cardinality categoricals. And so the idea here is that for categorical variables, wherein you have multiple binary columns, one of the things that you can do is use one-hot encoding to transform those categories into zeros or ones. And that's exactly what's going to be going on here. So in particular, I mentioned earlier that one-hot encoders were being used earlier with respect to date times. That same pattern is going to be playing out here as well. And then finally, what we're going to be doing is we are, so all of those different transformations that I just talked about, handling different data types, missing values, and converting them into forms that a machine learning model can understand. What we're going to do is we're going to package all of those together into a transformers variable right here. So we're combining all of those. And then what we're doing is we're putting it into a column transformer object here and passing it through the system. So that section is really kind of the end of being able to talk about what we're doing to the data to modify it ahead of machine learning. From what we're doing from here on out, what we're doing is we're slicing and dicing the data in order to prepare it for machine learning. In particular, what we use is a train test validation or a train validation test split. And the idea is that of the 100% of data that you have, 60% of it is being used for the training of the model, 20% is being used for validation, and 20% is being used for the testing data. So you'll notice then that 40% of the data is not being used to train the model at all. The reasons behind this are kind of a little bit deeper and statistical than what we have to get into right now, but you can sort of think about it as thinking about how well a student does on a test, for example. If you gave a student a test but gave them the answers for that test directly ahead of time, they can just memorize the answers to that, and you wouldn't really say that they've been learning anything as a result. In this context, this is much more akin to giving a student a whole bunch of material to study on, and then you're testing them on examples, and in particular, 40% of the data set that they have never seen before. And then the splitting between validation and test is really there because we want to guard against this idea of overfitting to a particular data set. So for example, if we train a model and it does really well on 20% of the data, but then it fails on the remaining 20%, then it's a really good indication that in fact, the model is only learning the 20%. It's not learning the broader concepts that we want to teach it. So that's kind of the motivation behind this data split that we're going to be engaging with here. So in particular, so this code right here is just implementing directly what I said. We are going ahead and splitting the data between training, validation, and testing. And in particular, what we're going to do here is we're going to train so after we've gone ahead and split it up, we've transformed our data earlier, split it up. What we're going to then do here is actually train the classification model. And a number of things are going to happen here. So we talked earlier about being able to monitor the output of it, be able to figure out the related metrics that we want to keep track of, and then change model parameters as well between different runs. So that's kind of happening at one level above this overall process. But in general, what we're the code in 26 is then taking all the work that we've done so far and actually going ahead and training the final model. So what we're doing is we're going to be creating a separate pipeline just to transform the validation set. We need to transform the training, the validation, and the test data. So this aspect is handling the validation. And then what we're doing is we're declaring a new function called objective, and we are going ahead and using MLflow to start a new run. So keep in mind, this is one version of what a set of transformations can look like. And so this counts as one run. And what we're doing is we're going ahead and declaring a model object. And one of the things that you'll notice throughout this notebook, but then if you get a model in production as well, one of the things that you can then do is you can use MLflow to then log particular elements of the overall process. And so in particular, what we're doing here is we're logging the data set as the training data set that is going to be used to train this model. We declare a pipeline. So again, what this does is it selects the columns that we want, it processes them, and then we declare a final model that's going to be doing the training. We're setting up automatic logging here to automatically log the input samples metrics parameters that we're using as part of this training process. And then what we do is we call the fit function. This fit function is actually doing the training. It's taking the training data, taking the values that we want to predict, in this case churn, and fitting it to that. And then what we're doing from here on out is we are actually logging the different metrics that are coming out as a result of the model. So after you're done with this line of code, the model has been trained, and we have that as a model object that then we can start to take the training and testing data in, pass that data into it, get the predictions out on the other end, and see how those predictions look. And so that's what we're doing here. So in particular, we are doing the training evaluation result right here, the validation data set right here, and the testing set right here. And you'll notice that generally the code, these three code blocks right here, are extremely similar to each other because the code being used to make a prediction is the same. The only variation is what data set is giving rise to that prediction. We're going ahead and grabbing the results right here, and we are then computing loss. And from there on out, we're computing a few other metrics, and then ultimately we have a final object that is getting a final dictionary that's getting returned here. That is that corresponds to the results that we're getting out of the process. So let's assume that we are dealing with no hyperparameters in that case, and we're just running everything vanilla default out of the box. One of the things that you would want to be doing if you were really trying to figure out what the optimal model setup is you'd want to vary these things called hyperparameters. And one of the things that we're going to be doing then here is using what's called a hyperparameter space in order to configure what needs to be searched over. There are options that you can use when doing this that would specify multiple different values. In that case, it would default to what's called a grid search, and it searches through all different combinations of them. Or there are tuning methods that use local optimization techniques that then find better hyperparameters through an iterative process. So I'm not going to get too far into what each of these hyperparameters means. Just understand that these can be varied in order to further refine a model. Eventually, what we'd want to do is we would want to run these trials, and that's ultimately what we're going to do here. And you can see that for each of these trials, there are particular results coming out of them. So you can find that there's a bunch of warnings coming off of these, but these are ultimately the final results coming off of a number of these. So not going to get too far into that. The main thing to just keep in mind here is that these are the multiple iterations of the process, and eventually we come out with a final table here that then corresponds to the values that we're interested in to start thinking about how good the model is. One of the nice things that we can note really quickly is that the score that we were after here is extremely similar to each other, meaning that we're not really overfitting on one set versus the other. And we also then have a final visualization of what the overall process looked like. So for example, I mentioned the timestamps being handled. We have a number of imputers, transformations, encoders in order to give rise to the timestamp variables here. Finally, what we're going to do is we're going to do some cleanup related to the handling of the artifacts here. I'm not going to go too far into that. Instead, I want to get down here into feature importance. So feature importance is one of those things that has been increasingly important in recent years because people want to not only know why that a model is giving good predictions, they want to know why. What particular elements of the system or what particular features are allowing it to have the explanatory power that we want out of this. So SHAP is one method of talking about feature importance in order to get at explainability of the machine learning models. I'm not going to get super deep into what each of these means, but the general idea is that you can use SHAP and visualizations to then start thinking about which values going into the model then have non-zero SHAP numbers or SHAP values, I should say, that then would help you to start thinking about, well, this particular variable is really important for the final predictions that we are generating. And so in general, this is ranked feature value with country, age group, event count, and gender being the most, having the highest SHAP values. There are other sort of visualizations that you can use in order to think about the quality of the output here as well. In particular, the code automatically generates visualizations related to confusion matrices, ROC, and precision recall curves for the validation data sets. So a confusion matrix works when we have a categorical variable, a binary variable in this case, that we're trying to predict churn or not churn. And if you've ever heard the idea of false positives, false negatives, true positives, true negatives, then you're sort of familiar with what's going on here. In general, we want to be trying to maximize the values in the true up here in the upper left and the lower right. And the idea then is that if we predicted that it is 1 and it is truly a 1, then this is how often that happens. And then if this is a 0 and we predict it as a 0, this is what happens. These two values are about false positives and false negatives. We want to avoid those for obvious reasons. Additionally, ROC can be used. One of the things that you can do is look at the ratio between the false positive rate and the true positive rate and graph them against each other. And the idea is you can then think about how much, there's a metric then called area under the curve, and represented as AUC, that then corresponds to the area that goes between the diagonal and the curve that you've created as part of the ROC curve analysis. And then finally, you can duplicate that as part of the precision recall curve in the same sort of way. So through all of that, we've dealt with our data, transformed our data, done a ton of stuff with it. But now we actually, but as part of all of that, I called out in a few different places that MLflow was actually keeping track of some of the individual elements of the system as we were going through the process. If we wanted to then go back into MLflow and specifically evaluate those, we could. But instead, let's go ahead and say, we've done that, we like it, it's time to go ahead and register it. One of the things that you can then do is you can then go ahead and register it. When I last ran this, the model already existed. And so there's two things. If the model didn't exist, it would then go ahead and register it. But interestingly, one of the things you can notice here is that when I ran this much earlier today, you'll notice that the model in that case already existed, and I tried to register over it. And one of the things you can note about the output here is that if you go ahead and try to register a model where a model already exists, it'll create a new version of that model. What this means is that there's actually built-in versioning for you to then be able to keep track of your models over time. This is especially useful if you want to start exploring concerns around model drift or data drift. It means that you can retrain your models and still keep track of which versions are then ultimately getting deployed and used, and what the inputs to the creation of those models were. So you don't have to, so as a data scientist, one of the things that you may have done traditionally was to create great model _1, great model _2, great model _3. Total mess, right? Instead, versioning gets around that by automatically keeping track of which version of the model you're on. So we've gone through the process of monitoring our data, setting off runs, figuring out the visualizations coming off of that, assessing quality, doing all that, and we finally have a model that we really like. Well, it's time to actually go ahead and try to get value out of this by going ahead and deploying it and trying to either look at batch inference or real-time inference. And so from that last step, just assume that we have a model in our MLflow registry, and it's time to really start using that. Similar to what we do in the past, we need to install some packages and do some basic setup. But what we would then go ahead and do is we want to then deploy it for the purposes of batch inference. So one of the things that we're going to do here is we can go ahead and declare a UDF, or a user-defined function. And we're going to be going ahead and doing that. So in particular, we are defining a function called predict churn. There's a variation of this function that you'll be seeing later on within the data engineering section. Just understand that broadly it does the same thing. And then what we're going to do is we can then go ahead and take the data that we had created previously, and we can then go ahead and take the table and create a new column that then corresponds to whether or not the churn prediction happens. So this is the entire column. This is the entire table. The churn prediction is way off to the right. But then what you could also do is if you wanted a more pure pandas inference sort of setup, if you had a relatively small data set, kind of like the one we're working with, you can also then go ahead and do it through this route as well. Again, what we're going to do is we're going to set the registry UI. We're going to find the model's artifact repository here corresponding to the model that we created at production, and we're going to go ahead and download it. We're going to go ahead and download the requirements. We're going to install those requirements, rerun the initial setup, and then what we can actually do is we can then go ahead and look at taking the model into storing it in local memory and then running predictions against it. So in particular, what we do here is we load that model. We can then go ahead and grab the required features related to making the predictions. And then what we do is we run the predict on it. And so in particular, what we then get out of this are 3 different predictions. So in this case, there's somebody in the US, and let's see, and here's the churn prediction. So this person is likely to churn, and so is the third, but the second one isn't. So let's just say that we're happy with everything so far, and we want to then go ahead and deploy it by endpoint. This part would have taken the longest out of everything we're talking about here, any one individual step outside of the runs themselves, because what we actually have to do is we have to go ahead and create an endpoint that will then store this model so that then we can directly ping it and make predictions against it. So just really quickly, what we do is we go ahead and grab we get the Databricks client, and then we go ahead and use that client to create an endpoint. So in particular, there's a few different variables here that we go ahead and set up. Most of it's related to naming and sizing and versioning, but we go ahead and create this. And again, you can figure out by how long it took to run that this will take a few minutes to set up. But then ultimately, one of the things you can do is you can then go ahead and once it's been created and once the model has been deployed to it, what you can then do is you can then make predictions against it. And so that's exactly what we do here as well. And then finally, and then finally, what we actually do is we take so recall earlier that we were using the predictions locally in memory in order to predict churn. What we're doing here is recalling those, and so those 3 had, sorry. So those 3, so this is the raw data. This doesn't include the predictions yet. Instead, what we're doing is we're taking this data, we are loading it into a payload, and then we're taking that payload, passing it to the endpoint, and getting a prediction out. And earlier above, you could have noticed that it was 101. Those exact same predictions are coming through here. So so everything that we have right now, this is an end-to-end process, taking in data, transforming it, monitoring it, figuring out what the best run is, being able to then look at some of the metrics underlying that to validate that approach, and then ultimately getting predictions out on the other end. But all we have right now are just a bunch of numbers, right? What do you actually do in order to then put that into something useful? Well, that's really when a lot of the conversation around BI and dashboarding would come through. And that's kind of where this notebook is going to be leaving off here. So before so I'm now going to move on to talking a little bit about Gen AI. So Gen AI is really kind of going to be the last one of the last steps here in getting the full utility out of the system. So we made a bunch of predictions, but how are we actually going to then use that operationally, right? So again, let's transition from thinking about the prior data scientist persona that we created. Instead, we're going to be talking about Lisa, who's going to be a generative AI engineer. And so in her role, she's going to be using some of the AI techniques and AI systems that we have to specifically take the predictions coming out of the last step, use some of the generative AI approaches that we have, ultimately then to create a system that would be aimed at reducing customer churn. And the idea is that this is supposed to really be sitting on top of the work that Alice, who we're going to be dealing with later, and Mark, who we just finished dealing with, to be able to present a final solution to other people internally and to customers as well by interacting with them and trying to get them to not churn. So in particular, there's going to be a few different things that we are aiming at here. One, figuring out whether or not a customer is likely to churn. If they are likely to churn, grabbing their most recent order information, and then based on that recent order information, generating custom content that we can use in order to induce them to not churn. So what we're going to do is we're going to run the setup as we did in some of the prior steps. And so earlier, recall that we are figuring out if a customer is likely to churn. So in order to do that, we're going to be creating a function that has two separate things. We're going to be taking a customer ID as input and then generating a predicted churn status. And so again, the work that we just did as part of section 4, those last 3 notebooks, this is the payoff to that, wherein Lisa is going to be able to fully utilize that. So what we're doing here is we're going ahead and creating a new function called churn predictor. And what this does is it goes ahead and uses AI query. It invokes the endpoint that we've created in that last notebook and in that very bottom section of the last notebook. And then what we're going ahead is we're using a structure in order to take in the different variables that are used to create the used to generate a prediction, and then using the outputs here to return either one of two things. And so it'll return a string here. If it's a 0, then they're going to not be at risk. Otherwise, it's going to be at risk, right? And so this is defining the function that is then going to be structuring the input, pointing to the endpoint, and then modifying the output to indicate whether or not the person is likely or is not likely to churn. So in particular, what we're going to be doing here is, I mentioned earlier that user ID is a unique identifier, and from that we can then look up all of the other information that is contained here. What we do is we go ahead and call that function, and we use this unique identifier, and we get back that this person is actually at risk. And if you wanted to do this then across multiple different user IDs, you could do that as well. The idea would be to make the scale across your entire customer base who you aren't certain if they're going to churn. But at least for this person, they seem likely to churn. Next up, what you'd want to do is you'd want to then, from that point, you would then want to perform a lookup on their order information. So again, she's going to go ahead and create a new function, and what it's going to do is it's going to define it's going to return a table associated with the input here of the user ID that we'd created. We give it a function, we give it a comment in order to make it more comprehensible to somebody who might look at it later. And then what we're doing is we are going ahead and selecting the information that needs to be returned here from some of the data that we had earlier on the churn users that we're defining as a join down here. So this is kind of a very normal SQL query going on here in order to grab relevant information. The thing that really makes it unique and that's fully leveraging Databricks SQL is the fact that then this is being represented as a function that then she can deploy to look up a specific user ID. And then we're also going to be doing, just to verify that the person that we identified earlier who is at risk, we're going to run that, and we're going to get at that this guy's name is Christopher. He signed up on the web app in the US, and based on what we know earlier, he is likely to churn. So at this point in time, what we'd want to do is take the information that we have about Christopher and use that to create custom communication that hopefully can convince him to not churn. And so one of the things that we're going to do here is we're going to use Llama by default to create custom marketing copy on the fly. Now, for the interest of time, I'm not going to read through the entire prompt here. Prompt engineering is very much still an art instead of a science. There are a number of different recommendations that Databricks has for creating effective prompts, in particular being extremely explicit about what you're expecting out of the output, to going ahead and being extremely explicit about some of the different formatting decisions that you might be making, and being extremely explicit about what needs to be considered and what needs to be ignored are all within the scope of best practices. And as you read through that, you would see some of those. So for example, the prompt is extremely explicit on what the format of the incoming date is going to be looking like. And then in particular, it's being extremely explicit about the copy that is coming out the other end as well. So for example, never write short copy, or consider the total amount. So for example, if the total amount of the last one is less than $100, push for a discount. So if they're not a high spender, then discounts might appear more appealing. But regardless, after we've gone ahead and created a prompt, we now have a prompt that we're able to then use. And what we'd want to do is here we'd want to go ahead and create a new function, which we're going to call generate marketing copy. That what it does is it takes the user ID, the incoming user ID, all of the different variables that we had defined previously, and it's returning out a string, which is going to be the communication that we're ultimately sending off to the client. We're putting in a comment to make keeping track of it a little bit more easily. keeping track of it a little bit more easily. And then we're going ahead and figuring out which model we want to use as well. Earlier, in the prior section, I talked about how machine learning models have different hyperparameters. So too, when you're developing an AI system, which model you're using for prompting actually significantly varies the output. One of the things you can then note in a live Databricks environment is that we are hosting a number of different models that you can then choose between. In particular, in this case, I'm using the Meta Llama Instruct, the one with 7 billion parameters. And what I'm doing is I'm going ahead and creating a payload in this section that's going to be the concatenation of the prompt I'd created, and it's also then telling the model the customer details that we created that we're grabbing as part of the input as well. And then what we're doing is we're going ahead and calling that function that we just created. So in particular, this is the username, this is the user ID, the name, the other indicators that we had. And what we do is we then get out a custom communication. So in particular, it's personalized, it's been a while since your last purchase, and so on. And so, for example, in this case, you may want to perform some post-processing as well, because you probably don't want to send this bottommost sentence to the end user as well. So there's stuff like that so this is like one example, but keep in mind for all of the different models that you can create, for all of the different ways which you can structure a prompt, each one of those is going to very likely produce different outcomes for how the model wants to then generate text to communicate with the final end user. So, finally, this last section is sort of the most open-ended, and it's really the one that I would recommend. We're coming up here on time. It's really the one that I would encourage you to sort of play around with the most. It's going to be taking place within the Databricks Playground. And the idea behind the Databricks Playground is it's supposed to be a one-stop shop for being able to play with the different elements that you can customize inside of an agentic system or inside of an AI system, and really modify those in order to figure out what impacts on the final output for you tweaking individual elements of it. In the interest of time, I'm not going to be going super far into it, but just understand that the idea here is that you are going to be able to use agents and use these things called tools that are basically just functions that then call other agents or then call individual functions. So earlier, for example, we had defined a whole bunch of different user-defined functions, and those perform some operation on the data, on some sort of information we're providing to it as well, generally, right? Within the context of the playground, the idea is that you are able to then create slight modifications in those tools in your agents that then you can look at the output of in order to then keep track of it. And importantly as well, for getting these into production, you're then also able to use the evaluation system in order to then use either a synthetic question generation. So in that case, you can figure out how you can get question suggestions automatically from certain data sources that you've gone ahead and set up. Or alternatively, if you're interested in measuring the outputs of these systems as well, you can then use the AI judge in order to figure out how well does the output meet the expectations that you had set out before it. So we're coming up here on me talking for about an hour. Before I move on, and again, I'm leaving this last one as sort of like an open-ended invitation to do the exploration because the development of these systems is so extremely open-ended. I'm leaving that as a little bit of a open invitation for you to play around with it. Before I move on and pass it off here, does anybody have any questions? I'm not seeing anything in the chat. So I'll be sticking around in the Zoom chat for quite a while. So as you start to work through these notebooks, as you start to develop questions, we're very much here to help you. Feel free to paste any of the questions that you have in chat, and I can tackle them in that format. Alrighty here. So I think I would be handing it off to Mohan here, if I'm not mistaken.
That's right. I can take it, Zach. Thank you so much.
Wonderful. Good luck.
Let me share my screen. All right. Can you see my screen?
Yep, looks good.
Awesome. So thank you, Zach. Zach did the really heavy lifting in this demo because there was a lot of content he had to cover. This next section is going to feel like a breeze. So let's just reset on like the assets that we looked at, right? So when you did your install, you would have got a list of notebooks like this right at the end. And what we just walked through was basically the data science part and the generative AI part. I'm going to be focusing on section 3, which is the AI BI data warehousing. And if time permits, I will jump a little bit into the data governance part, right? But I know we're running a little bit short on time, so we'll see how it goes. So just to level set, as part of the install of this, as you can see, lots of tables were created, lots of notebooks were created. There were workflows were automatically executed for you and all that. And we are going to look at some of the assets that were created automatically for you. And those are basically at the end here, which is the Databricks AI BI dashboard. So there's 3 dashboards linked, and you can click on them and open them yourself. But I just wanted to give you that anchor so we know where we're starting from. And then based on that dashboard, we will then pivot to AI BI Genie, and I'll talk about both in the next 35 to 40 minutes or so, right? Before that, I wanted to just explore a little bit of what AI BI data warehousing means in the context of the Databricks workspace itself, right? So we have this menu item on the left here that says SQL, right? And you'll see SQL Editor, queries, dashboards, Genie alerts, query history, and SQL warehouses. So that's going to be essentially what we're looking at today. We're not going to touch on everything, but I'll show you a little bit of everything as much as possible. These dashboards are pre-created, so you don't have to create it. You can click one of them and open it in a new tab. I'll do that shortly. But let's start with the SQL Editor. So if you are like a BI user at your customer or just an analyst writing queries, you need a space from where you are going to write these queries, right? So that's the SQL Editor. So you can go to and start any query by clicking on new and say new query, and that's going to create your new query. And then you can save it. You can see there's a save button every time you write a query, and then you can go back and navigate all your queries in the queries tab, right? So that's just trying to orient you. One of the things, if you're not super familiar with how Databricks lays out objects, is that we have a catalog, a schema, and a table, like how Alex mentioned right at the beginning. And you can choose sort of your context for each session or set of queries by choosing your catalog right up here on the top. And so that's your catalog picker. I have access to lots of catalogs because I use this workspace for other things. And your schema. So in my case, I installed it in Lakehouse Retail 360, and the schema name is DB Demos. So that's our context. But you can also write the fully qualified name anytime you want. So if you set your catalog and schema up top, you just have to refer to the table name here. Otherwise, you would say catalog.schema.table, right? And if you wanted to, again, figure out where you were, you could just uncomment these, which is a command / on a Mac, and say, hey, what's the current catalog that's in that I'm working on? And it's starting up my warehouse here and says, oh, you are in Lakehouse Retail 360. And I can do the same for schema, and it's going to say, oh, you're in DB Demo. So it's like, okay, I'm anchored. I know where I'm working in. Now let me start writing some queries, right? And that query could be as simple as saying, show me account star from a particular table that I know is in the schema. Now, how do I know what tables are in the schema? I can uncomment this one and say, okay, show me all the tables. I've already established my catalog and my schema. And now I have a list of tables, right? Again, these were just to show you how you would figure out where you are before you actually start working. Now that I figured that out, I can write a query like this, and I have a count star from a specific table, and I can create a visualization, which you would just do plus, and you would say, create a visualization. It's going to default to what it thinks is the best. You can change it. Maybe I want a line. Line doesn't really make a lot of sense for a count. So I'm going to choose a counter and say, hey, okay, here's the count. I want to give it some label, nice count, whatever, doesn't matter, right? And I can save it. Now, notice this is the second visualization I created because I created an earlier visualization of the same thing with the proper name, right? So just to show you that from a specific query that you are writing in the SQL editor, you can create multiple visualizations using all of the visualizations available in AI BI dashboards, which if you want to find out what those are, is basically this long list here, right? So there's line bar, area pie, heat map. You can read through it. And depending on your use case, one of this will be applicable more than the other. Okay, so now that we have that, how do we get this visualization into a dashboard? You would just click on this little tilde icon here, and you would say add to dashboard. And when you do that, it's going to ask you, okay, do you want to add both visualizations? Now that I have two, so I may have n visualizations based on this query, right? I could add all of them, and it'll say, do you want to create a new dashboard, or do you want to add to an existing dashboard? And remember, we have existing dashboards because our demo installed a bunch of existing dashboards. And this workspace usage dashboard just comes out of the box for you when you set up your workspace in the free edition. So we have these pre-installed ones. I could use one of these, but let's just create a new dashboard and say, hey, a new test dashboard, right? Just to show what it looks like. So I added these two visualizations, which is just a counter. And then now I have this new essentially test dashboard that we created. And if you click on data here, there's an untitled data set, which is basically that query that I wrote, all right, which is this query. And then has this set of two visualizations that we brought in, right? So that's how you would navigate from writing a query, adding a visualization, and then adding that visualization to the dashboard. When you add the visualization to a dashboard, it automatically brings in the context of the data that you were working in, which is why we see this untitled data set. And it renamed it automatically, actually. So that's like the sort of I would say the actual base set of steps you need to know to actually create a query and create it to a dashboard. Now, that being said, let's go to the actual dashboards that were created by the demo. Now you can navigate from the notebook that you ran earlier when you did the setup, or under the SQL space here, you could navigate to dashboards, and you would see the three that are created by DB demos. You can sort by name. It's easy to navigate. And then let's open retail data quality statistics, right? And see what was installed. Okay, so it looks like this is a dashboard that has a bunch of visualizations that was auto created for us. And the first thing we should do, if somebody shares a dashboard with us, is try to figure out what are the data sets involved in this, right? So let's click on data on the left here, and you'll see there are 3 data sets. And a data set can be a table or it can be a query, right? So you can add any data source. You can see here that you can add a data source, and that'll ask you, oh, do you want to add this table into the context of this dashboard that you want to use? Or you can upload a file. So if you click on upload file, it'll say, hey, we support all of these formats, and you can bring a file. And so that file will land up in a Unity catalog volume, which is a secure part of, well, a volume that you have access to. So it's governed by Unity catalog access controls. And or you could write your own sort of data sets. So let me go back there. Or you could write your own queries and bring them in as data sets, which are these 3 that we're seeing are basically queries. If you look at this, it's a query that somebody wrote. In this case, the demo creators wrote, and you're just bringing that in. Now, typically, it's a mix of both, right? Sometimes you have pre-created queries that you worked on as an analyst, and so you brought that into a dashboard. Sometimes you start with an empty dashboard and you're just adding data sets and then building queries on top. Both are valid. It really depends on how you operate as in your role and your function, and gives you the flexibility of both, right? Which is why you can create from SQL or you can add a data source. Now that we have a data set, you can see the results here, but let's go back to the actual dashboard page. Now you see the title is new page, but you also see a plus here. What does that mean? That means in AIBI dashboards, we support multiple pages, right? So you could have a set of visualizations in this page, and you can create a new page and have another set of visualizations here. So think about it as like, okay, maybe I want to have like all of my aggregate visualizations in one page. And that's what my CEO cares about, for example. But I then want to have like more low-level details and more finer-grained dashboards in another page. And he doesn't care about that. So all he needs to focus on when you share this dashboard with him is the new page, or like rather in this case, we should rename it to something like, let's say, CEO Visual, right? Something. Right? So now he knows he only needs to care about this. And you can publish this dashboard and you can share this dashboard. So share is basically giving access to people in your organization. And publish is me publishing an official dashboard versus just the draft version. Because right now I'm in the draft version, and if I do publish, let's see what it does. It's going to publish, and there's a new link, and this is the published version of the dashboard. So the difference between this link and the other link is that you see that data tab and all of the edit options went away, because this is all they want to look at, right? This is all a viewer wants to look at. Now I'm going to go back to the draft version of this so we can work on it. Yeah, so that was the draft version rather. So yeah, I'm in the draft version, sorry. So that's how you would add data and do all of these things. Now, Databricks, as you know, and as like Drew mentioned at the beginning, has tried to infuse AI in lots of parts of the platform. And that you can do within a dashboard as well. So if you hover over these, these visualizations, you'll see that there's this assistant preview, right? So that's an AI assistant. It's an LLM that Databricks is hosting, and you can ask it questions. So let me try to create a new visualization. And to create a new visualization, you would scroll to the bottom here and look at this blue set of functions here. And I would say add visualization. And I want to place it somewhere here. And you can actually ask the assistants to create a chart, which is what the prompt is, right? Now, I could ask my own question, but let's see what it's already telling me that there are some logical sets of questions I could ask. So let me do that. I'm going to say, OK, show me the output record summary. And the assistant actually drafted a query and created this particular visualization for me. Right now, it's like a table format, which sort of makes sense, maybe in this case. I could accept or reject it or ask it a question in a different way. All that is to show that you could create your own visualizations, but you don't have to actually click every little button in a visualization to create it. You could just chat with AI to create it. If you click on any of these existing ones, let's take a look at the ingestion rate. It'll tell you the details for the widget on the right side, right? So it says, OK, this is a counter visualization, which is similar to the one I showed you when I created my first test query. And you can modify these headings and descriptions and titles and stuff like that. Now, if you click the next one, now this is a line chart, and it gives you more options, like what's your x-axis, what's your y-axis, right? And as you get used to working with the assistant, you could basically say, hey, create a line graph for me based on, with the x-axis as daily and the y-axis as these two measures. And it would do that for you. So that's the power of dashboarding, in that you can create your own dashboards. You can create it by hand by specifying all these options, or you could ask the assistant to craft it for you and go back and forth trying to iterate, right? So you have all of these tools at your disposal, and you could create these really interesting and impressive dashboards. A couple of things that we will not be covering today is that actual dashboards, the dashboard feature is quite comprehensive. Like now we have like cross tabs and cross filters and a lot of things. So you could apply global filters here, and that filter is going to apply to all of the pages in the dashboard, right? So you can do like pretty interesting things. We have internal dashboards that drill through like various sets of hierarchies, for example. So you can do really cool things in dashboards. Okay, so that being said, there are a couple of other dashboards. Now this retail customer churn dashboard and the prediction dashboard are based on the ML side of the fence that Zach just talked about. So let's also click through on that, because we'll see some different visualizations. This is the published version of the dashboard. And you can see that you can do like, horizontal or vertical bar charts. You can just expose a table. You can do pie. You can do all of these visualizations. And again, you can use AI to ask follow-up questions. Now, the first thing I showed you was using Assistant to help craft a particular visualization. Now we're going to do something else, which is Genie. And Genie is basically you're chatting with an LLM to figure out how to make sense of your data, right? It's not actually helping you create the visualization. It's saying, I have this particular data set, help me understand it, right? So the prompt is different because now I'm a consumer of the dashboard. Let's say I'm the CEO, and I want to ask a follow-up question. So let's say we have this visualization which says, okay, at-risk customers have device protection. And I say, okay, I want to ask a question, and I say, oh, like, what are we talking about? I see a percentage here, but how many records am I dealing with? Maybe I want to understand the data set, and I can say, show me the charts underlying data, right? And it's going to go and do some analysis, basically craft the set of steps that any LLM would do and say, okay, this is what I see, right? So there is apparently a field called churn, which I may not have known ahead of time. And there's a field called platform, and there's an event count. And based on that, we have said that this is, the visualization is based on this, right? And this is how I can ask questions of my data. But I can do more interesting things, right? So let me show you how you would actually create a Genie space separately in which you can just ask questions without worrying about visualizations. It will also show you visualizations, but it's a slightly different lens. So in this case, we've said we can use Assistant to ask a few questions to create the visualization. Then as a consumer, I can use Genie to ask questions of the data that I am looking at. But now I want to dive a little bit deeper. And to dive a little bit deeper, there's a couple of different ways I can do this. So if I was in the draft version, I could go to this little kebab menu right at the top, and I could say, open a Genie space, right? And it is going to bring the context of these tables that are in this data set into a Genie space. So I'll do that first, and then I'll show you how to create a Genie space separately, right? It's a little bit confusing if you see it the first time, but let's do both. So first I'm going to do this draft Genie space. And what it's going to do is create a Genie space for me. Now you see the UI has changed, the visualizations have gone away. What this is a way for me to ask questions of my data using natural language, right? And it prompts me with some sample questions based on what it has seen of the metadata of these objects. It knows the names of these tables. It knows the columns in these tables, right? So using those contexts, it is saying, maybe this is what you are trying to explore. But let's say it didn't have any of these questions and it couldn't make any sense. It would at least have the first one, which is explain this data set. So let's try that. So I'm saying, okay, what tables are there and how are they connected? Now, if your data model, the way you modeled your table, had a primary key and a foreign key, then Genie would say, I found these relationships. But in these data sets that we created, remember, these was just SQL queries that we saved as data sets. So they're not actual tables, right? So there is no explicit primary key foreign key relationship. But it says, okay, each focuses on a different aspect of churn analysis. It also prompts you at the bottom for some more questions. So I could keep chatting with it, and I can also say yes and fix it if I know what I am doing. So let's do what is the total monthly revenue at risk from churn and see what it crafts, right? So it's saying, hey, I'm drafting a step-by-step plan. I'm going to run some calculations, going to give back and says, okay, this is what I came up with. Now, if you knew your data, you could verify that Genie was not hallucinating by clicking the code and saying, okay, this is what it's doing. I have a table of monthly revenue risk. I can click here, and the only column there is MRR at risk. And I asked for the total amount of MRR. So it said sum of MRR. Does this make sense, right? It's not inventing this based on some random heuristic. It's actually querying the table that's sitting there that you brought into this data set. And I could do, I could give it some feedback. It could say, yeah, I like it. And then it's predicting, it's prompting you for more questions. So what is the advantage of this? The advantage of this is if somebody gives you a list of data sets, as let's say a data engineer developing a data engineering pipeline, somebody gave you a bunch of bronze tables, right? Bronze are, maybe not very clean data. Maybe it has data quality issues, it has all of these things. You could start analyzing that data using Genie without writing queries of your own. And in this case, it says, I can't break it down by platform because monthly revenue risk doesn't have that platform, which is totally true, right? So let's see if platform is there. So it says, oh, it's there in the subscription table, right? So maybe I can reframe my question and say, what about if you check the this table, right? And see what it says, right? So again, think of it as exploring the data, understanding the data. You're not going to get all the perfect answers all the time, but it's saying, okay, now I'm missing something else, right? So you're figuring out relationships between tables that don't exist, and you're figuring out what kind of data elements are there or not there. And it's a way for you to understand that particular data set. Once you have all of your foundations established, you can actually publish it to a larger audience who can reuse all of the lessons that you learned while creating the Genie space, right? I will flip over to the docs here just to give you a grounding and go to this one, right? So you'll notice we have an entire page on how you curate an effective Genie space. So it says start small, have a domain expert define the space, define the purpose of your space, add metadata synonyms. So it's not that you're just throwing a bunch of data at an LLM and hoping you get lucky. You have to spend some time making sure the space is good for what the purpose it's trying to do, right? And that's what you would do as a Genie space creator. And then somebody else is a Genie space consumer who's just asking questions based on what you told them. Now, if I flip back to the other page, I'm going to show you another Genie space. Actually, let's create a new one just to show from the beginning. So if you flip to the Explorer here on the left and go to Genie and say new, you can create a new Genie space and it'll say, what data do you want to bring in? And let me say, I just want to bring in churn users. Actually, let me go to all and look at the Lakehouse Retail, the 360, and I'll bring in just these two bronze tables, right? So bronze in my in the sort of the medallion architecture, if you've heard about it, is the rawest form of data. Maybe you have a raw layer, but it's essentially not cleansed, right? It's not silver, it's not gold, it's not really ready for consumption, let's say. But it's good for investigation. So I created this space, and I have two sets of tables, and I could say, hey, explain the data set. Same thing again. I'm trying to explore what's happening and says, okay, now it says something slightly interesting because it found a commonality. There is no, I've not specifically said there's any relationship between these tables, but it noticed that there's a user ID in orders and there is an ID in users. And it's making all of these relationships. So let's, we can ask it some interesting questions here. So let's say, okay, let's say what's the average spending amount per user, and it is going to run a query and tell you, and my guess is it's going to query the orders table, but we'll find out, right? Yeah, it queried the orders table, right? It's sort of obvious that the amount would be in the orders table. And you can go back and forth with Genie trying to curate your space. But let's actually look at a pre-created space. So I created this scratch space earlier just to show you a few things. And I brought in a lot of these churn tables earlier. And I added one other thing here, which is this benchmark question, if I remember right. Actually, I created it in a different space, right? I think I added it to metro view space. Yeah. Okay, cool. So let me show you what a benchmark question is. A benchmark question is you as a space creator, or as you analyze the data, you figure out that Genie is responding correctly with some correct responses to SQL. And you registering that as a benchmark question ensures that the next time Genie sees a similar question, it has something to compare it to, right? So the benchmark results, you're saying is a good query. And if Genie creates a bad query, how do you know it's a bad query, right? It doesn't have anything to compare it to. So as a space creator, you're saying this is a benchmark query for this type of question. And you could create multiple of these. So in this case, it's a number of active and churned users sliced by dimensions of age group and country. So there's two essentially measures, and we're slicing it by two dimensions. And it's doing this particular calculation. And you're saying this is good. If a new user comes in and writes a query that asks a similar thing, what should I compare it to? Here's the benchmark query, right? And you could create multiple of these. Now, I want to do a quick pivot here to connect to something we mentioned earlier. So if you go back to our notebook, I mentioned that I would touch on metric space, Unity catalog if time permits, right? So let me actually show you what I mean. So if you go to your notebook that you created, let me navigate again there. I mean the original notebook that you created. We said that there was, we'll talk about data, the actual BI dashboarding and the Genie, but we'll also talk about metric views. What are metric views? This is section 2. It's basically a semantic layer, right? A business user does not understand a technical jargon, right? So most BI layers will build some sort of business layer on top. Then there are tools out there that only do this, like AtScale, for example. So they're building a business-friendly semantic layer. That's totally fine. But that I could do simply with a view, right? I just need a view in which I rename technical terms to business terms and I'm good. Well, it's more than that. What is a UC metric view, right? It's quite different. It actually allows you to slice and dice by multiple dimensions and multiple measures at the same time without you defining those in a view, right? So it's very extensible. And you can create a metric view with Databricks Assistant. As shown in this notebook, you can try it on your own. And the whole code is expressed in the form of YAML. And it basically says, these are my dimensions and these are my measures. And if I have multiple tables in there, I'll also mention these are my joins conditions. But I'm not writing specifically any views to say, group by age group or group by something else. So the metric view doesn't include this. The metric view does this on the fly, depending on how you want to ask questions of your data, right? So let's go to a metric view that was created automatically for us and see what it looks like. So if you go to your, all the assets that were created, you'll see this churn users metric view. And if you click onto it, you can see the definition of it, which is, it's pretty long, but fundamentally there's like 3 or 4 sections, right? There's a filter, meaning like I don't care about all of the data, I care about data from some period of time, let's say. A join, so I'm using churn users here and joining to churn orders and saying, hey, use the user ID to join. A bunch of dimensions. Think of this as the thing that you would use in a group by in individual queries, right? So instead of writing 6 queries with 6 different group bys, I'm just defining it once in a metric view. And then measures, which are the things that you would do a count or a sum or aggregation by, right? Now notice they're completely separate from each other. Like, what if I wanted to do count of distinct user ID by age group? I would write a query for that, right? Typically, I would say count of this by age group by this. What if I wanted to do count of distinct ID by canal? Do something else. So instead of writing all of these, the metric view allows you to express it as dimensions and measures and then use it. So now I want to go back to my Genie space where I added the metric view. And you'll see the only object I brought in is that metric view we looked at. Again, the same thing, same set of measures, same set of dimensions. And I just added that one benchmark question, right? Now, if I say show churned users by country, let's take a look at the query that it writes. It is going to take this basically this measure, which is churned users, and it is going to group by country, right? But notice how the code looks a little bit different. It says select country, which is a dimension, and then a measure, and it's totally good. You could rewrite this yourself as saying select the same things, group by country, right? And you would say sum of churn users. Instead, we are saying measure. But what's the advantage? The advantage is, I would say, extend this to also a slice by dimension, let's say age group, right? Because that's my other dimension here. And I could keep iterating on this. So now Genie is saying, okay, you want me to actually slice and dice by more than one, and it does it correctly, right? Because it's now grouping by country and age group and giving you churned users. But look at the code. The code essentially stayed the same, and you didn't have to create 2 different views or one view that you had to edit over time. You just define the measures and you just define the dimensions once. So this is a really cool way in which you would define these metric views, which are business-friendly definitions of data sets. And allow your business users to, go and explore this data and slice and dice it however they want. Metric views have some really cool sort of performance things behind the hood, which we won't have time to get into. But they will be automatically materialized in future, so that anytime there's a data change, let's say in one of these source tables that's coming in through a streaming pipeline, we'll automatically refresh the metric view as a materialized metric view. So there's really cool things coming. And I would encourage you, if you are new to Databricks and you're doing any kind of analysis, to think beyond just views for your slicing and dicing of data, and think about metric views. It's very, very extensible. One other thing I wanted to touch on, since we're almost at time, is if you go to query history. So we touched on SQL Editor, we touched on dashboards, we touched on Genie. If you go to queries first, you'll see all of the queries that you saved. So in my case, I just had that one query, remember, where we had this scratch query. So we only have that query. And if you go to query history, you should see all of the queries that you ever ran, right? And an administrator would see obviously everything that everybody ran, but you can filter by users here. So in my case, I'm just filtering for myself, and I'm the only user in this workspace. But you can see all of these queries, and these queries also tell you where you ran them. So I ran them in a new space, I ran them through the dashboard, I ran them through scratch query, whatever, right? So it's giving you a full sort of, I would say, operational lineage of where people ran this from, which is very, very important for like observability from a platform perspective. Maybe you as an individual user don't care about it much, but it's very, very important from a platform perspective. I think I'm on time, and I want to give Alex time to run his thing. So I hope that was like a good primer on Genie spaces, dashboards, and metric views. And I hope you can have fun with the data engineering part of this. Alex, do I pass to you?
Why not? Let's do it.
Awesome. Thank you.
Great job, Mohan. All right. How are we feeling? 111 and 11:11, I guess. Let's actually take just a couple of minutes. Let's do a quick bio break. We'll start up here at 11:15 Pacific, and we'll kind of knock the last 40 minutes out and then call it a workshop. So I'll see you all in about, let's do about 3-4 minutes or so. All right, I have 11:15 here, so let's see. My face is on, screen is shared. So we're back. My favorite 24 of y'all that stuck around till the end here. Yeah, no, it's good. I think there's a lot of the Databricks platform. I hope you've kind of seen that so far today, just with all of the data science integrations that Zachary went over, all of the BI capabilities, semantic layers, and way for business analysts to get data out of Databricks and into their stakeholders' hands that Mohan showed. There's a lot to the platform, right? And we understand that can be overwhelming. And to us, it's just where can we like just fit into your stack? Where are you having pain right now? And honestly, Databricks probably has a solution, whether that pain is on the natural language querying of your structured data, whether it's on the organization and governance of your traditional machine learning models, whether it's on the same kind of guardrails around your large language models, right? There's a couple of good questions around AI judges and things going on. And the AI, generative AI space obviously is evolving very quickly, and Databricks' products and offerings on that is also evolving super quickly as well. But definitely recommend keeping abreast there. And I think the last thing that really stuck out to me from the last couple of hours was just the open source underpinnings of everything. And we'll get into more on that here when we start touching on some of the data engineering with Spark workloads and Databricks. But MLflow, for example, that's what Zachary brought up. MLflow is the main library and engine that we use to track all of our models, your traditional models, as well as your generative AI models now with MLflow 3.0. So this is where you can have your model registry, you can see your model versions, and with new generative AI capabilities, you can get traces as well. And I think there was a chat earlier where I mentioned some of the integrations between Databricks and Vertex. And again, we do see it as a collaboration, right? It's use the right tool for the job. That again, like where do you have pain? Is it in the governance of your AI models? Is it in the training of your AI models? Is it getting data to your AI models or vice versa, right? But yeah, like I said, MLflow 3.0 and MLflow is an entirely open source product. Databricks contributes to it regularly, but it can also be spun up on its own. Same thing with Apache Spark, as you all may know, that's where Databricks started, especially in the open source realm, just providing that managed distributed engineering workloads. And of course, Delta Lake, as well as other Unity catalog, all of these protocols are now open source, and the features are often driven by the community or the organizations that are trying to get the most out of those technologies. But bringing it back a little bit, I think that the ML, I think Mohan and Zachary got all the sexy stuff, right? Excuse my language there, but the ML, AI, the querying, the natural language interfaces, right? Like that's all the big buzzwords going on right now. And it is really important for how to make data-driven decisions at your organization is through that final consumption layer, right? That augmented AI intelligence layer as well. But without the data engineering, right, you can't really do any of that. How are you going to make these awesome Genie spaces and dashboards without getting the data ready for that? How can you train your models or fine tune your LLMs or trust your RAG chatbot output if you don't have the data prepared and organized? And again, this is really where Databricks' bread and butter originated. How do we clean up, prepare, organize, and govern this data at big data scale, at terabytes, at petabytes of scale on the cloud, in your network? And how do we integrate that with the rest of your technologies across your ecosystem? So I think the medallion architecture has been mentioned a couple times today, but it's definitely worth re-highlighting again. So the medallion lakehouse architecture is an architecture decision that Databricks really promotes, and we've actually seen it expand beyond Databricks now. Even your BigQueries, your Snowflakes of the world, they all kind of now pitch this lakehouse architecture. In fact, I've done some work with some customers doing Big Lake, what's some of the Iceberg connections now they do with yeah, with Big Lake. So how do we kind of build this lake house, this interoperable lake house on kind of native GCP products? And you can also integrate Big Lake now with BigQuery, which is also really interesting. And then Databricks can also act as that metadata layer, that governance layer on top of it. And again, just how do we become more interoperable with the rest of your data systems? But the medallion architecture at a high level, It's called the medallion architecture because, again, we all get the Olympic medals, right? So February 2026 call out. But we have bronze, silver, gold in terms of the metals of our medallion architecture. Your bronze layer is going to be your raw data. And this can be any data type. And this is where really the lakehouse paradigm differs from a warehouse, right? This can be unstructured, semi-structured, or structured data coming into your GCS buckets. We want to plant it there. We want to have tables that represent that data set and make sure that it's governed and part of the actual whole. So we'll look at this with volumes as well as with our bronze tables. We want to make sure that we're ingesting our data appropriately, whether it's batch or streaming. And we also don't really want to have to rewrite our pipelines if we decide to change our mind on that. I think, again, coming from a practitioner background, everybody wants data faster and faster. So you start with a batch pipeline that's maybe running once a day. Now it's running once an hour. Now it's running once every 30 minutes. And now it's almost going to become micro batch or streaming. We don't really want to have to rewrite our pipelines each of those times. Next, once we have all of our data ingested and we can see what it looks like from source, we then want to clean it up, add in our expectations, maybe drop rows without our customer ID, maybe drop rows if they are too outlier-ish, right? How do we clean and prepare our data? This is also where we can do joins, as we can see here. Let me zoom in. We can actually join, for example, our customers and transactions and get a joined table of all of our customer transactions. Same thing with our account opportunities. Typically, the silver layer is where your business analyst or your data scientists will go to then create more reportable data products. So for example, a business analyst may go into silver, figure out that they want this leaderboard for which customers are spending the most, draft a SQL query for that, generate a materialized view, and now we can build a Genie space or a dashboard that's just a select star from some of these tables, right? And that could even be on a separate platform like Looker too, right? Same thing for your data scientist, as we saw from Zachary's perspective. He created this table called churn features, and then from that churn features table, which was derived from silver layer kind of data, we were then able to train our machine learning models. So this is one example of how we recommend doing this. I've seen a couple variants of this, but at a 10,000 foot view, make sure to get your raw data in, clean it up and prepare it for analysis, and then finally get your reporting layer objects kind of ready to go. So this is obviously easier said than done. And if any of y'all have played around with Apache Spark or PySpark, either in its Scala form or like PySpark form, you also know that writing distributed queries and distributed code to do this data processing at big data scale can also be kind of annoying as well. So today I'm going to show you a little bit of an introduction into Lakeflow pipelines, which is one of Databricks' newest open source products, which I'll talk about in a second. Actually, we'll talk about it now, actually. But we actually open sourced our declarative pipelines into the Spark project earlier this summer. And again, the idea of these declarative pipelines is how do we have one type of declaration, right? How can we create one pipeline to work for both batch use cases, streaming use cases? How do we make sure it incorporates expectations and data quality? And again, how do we just accelerate the way for people to ingest and transform and create this medallion architecture in the first place? So you may have seen a lot of things around Lakeflow, whether it's Lakeflow Connect, Lakeflow Declarative Pipelines, Lakeflow Jobs. We'll touch a little bit of those at a high level here as well. So let's actually go back to our project. In our example that we've done so far for our customer 360, we've actually started from our silver tables, right? We've been that predictive intelligence engineer. We've been that data scientist. And now we need to kind of go back, right? What was the data that we actually brought in? How did we clean and prepare it for our warehousing? And what actually needed to happen in those steps? And how do we make sure that our pipeline is scalable and production ready in case my number of customers goes viral overnight or something? So what I'm doing here is I'm opening up in my file explorer here. I'm opening up data ingestion, and we're just going to go to 0.1.1. You can ignore anything that asks you to activate previews or displays. I'm just using the regular kind of notebook here, and we'll talk about the pipeline aspect here in a second. So again, let's talk about the pain that we are trying to solve here with these declarative pipelines. Hard coding data ingestion sucks. Hard coding transformations is terrible, right? Building your own in-house custom frameworks to enforce quality and testing is also kind of frustrating. Even bringing in other open source solutions like Great Expectations and having that work with your own data sets in Spark is also pretty frustrating. So again, we want to just simplify this process, accelerate the time and efficiency of your engineers to be bringing in more data at a higher rate of velocity than if they were having to write all of this native Spark code on their own. So in our goal here, we have data that we have stored in cloud storage. We are going to ingest it in using declarative pipelines. Oh, here's my architecture diagram. So we have maybe app click events. Maybe we have orders stored in SQL Server. Maybe we have some Salesforce data. We want to bring in all of these data sources from source, create our bronze. I need my pen here. Create my bronze level. Ooh, let me see if my pen can work. Ooh, create my bronze level data here, create my silver layer tables here, and then finally create my gold leaderboards all the way out here. So that's kind of our goal with these declarative pipelines. So first, let's start on the left, right? It's always best to start planning your data journey with what data do you even want to bring into your data system. So if you just have a normal API or FTP server, it's fairly straightforward to just replicate that API response or that FTP content into a cloud storage bucket. But if you're doing an external connection, maybe connecting something from SQL Server or from Salesforce or from Workday, that can be a little bit more of a pain. I'm not going to demo it inside of Databricks Free Edition, but I definitely wanted to highlight this product known as Lakeflow Connect. Lakeflow Connect is a connector to external sources, right? So for example, the Salesforce connector allowed Porsche to really quickly ingest data from Salesforce. Behind the scenes, it's going to use either the data cloud or JDBC or other esoteric ways of bringing in that data, but it's abstracted away for you. We have a full list of connectors in our documentation. Oh, I already had it up. I wonder how many times I've gone over this. But yeah, we have a lot of different ways to manage these connectors and bring the data in. And again, at a 10,000 foot view, what is this trying to do? We want to use minimal clicks, minimal code, minimal UI to get data from an external system into your GCS buckets, right? Into a place where we can initialize this bronze representation of the data. So note that various connectors are coming out all the time, and some are in various release states. Some of the most popular, again, SQL Server, Salesforce, Workday. I think those are the most widely used connectors so far, but more are coming all the time. I think we're actually rolling out a Postgres connector here soon as well. And again, this is considered one way. We are ingesting data from Salesforce into a Unity Catalog Databricks managed GCS bucket, which from there we can then ingest into downstream tables. So I've mentioned these volumes, these Unity Catalog buckets. What do those actually look like? Well, we can actually go see one. If we go to our catalog, I'm going to open up my DB demos retail. And you notice we have these tables that were created as well as our models and functions. I was actually trying to follow along with stuff as we were going. But we also have volume. So what is a volume? A volume is just a cloud storage bucket. Most of the time, this will be a cloud storage bucket just on your cloud provider. So this would be a GCS bucket behind the scenes, and Databricks manages it. So it's, again, part of your overall governance system. It allows you to get lineage to understand which bucket did data come from to then get into my pipelines. So for example, here we can see within my Customer 360 bucket, I can have individual folders representing each of my unique data sources. So the idea here is that this users folder, right? All of these, I don't even know, this Parquet, Woof. I think this is all Parquet files. All of these individual Parquet files, it doesn't matter to me where these came from, right? These could have come from an API. This could have come from a Lakeflow Connect ingestion. Could have come from even something external like Fivetran or whatever, right? We've grabbed data, we've dumped it into my bucket, and it's loaded up here. These are the raw files. Note, this is how you can also incorporate semi-structured and unstructured data. In a volume, we can have PDFs or images or texts. Again, another common, maybe more large language model Gen AI use case. I want to bring in all the PDFs related to my like organizational cybersecurity protocols, right? Let's dump those into a cloud storage bucket that's monitored as a volume. We can then treat that as our bronze layer. We can write a pipeline to do OCR, extract the text, extract the information from these PDFs, save them to a vector search. Yeah, see where we're going with this? And now we can rig up a RAG agent. So the RAG agent will then query the vector search and bring back information. And now we have a scalable pipeline, right? As people generate more PDFs, as soon as they get dropped into this bucket, that can be a file trigger to trigger an update to the vector search, which then now provides the latest and greatest documents to your RAG agents. And again, the same, if you go back 10,000 feet, the same philosophy just applies to a regular data set as well. We can bring in a CSV into a bucket that can trigger a pipeline to bring in that data and save it to a table, which can then update some materialized views downstream. And now that latest and greatest CSV data is now updated on your BI dashboard. That's really the power of Databricks when you think about it. How do we, instead of having a unique esoteric solution for every bit of the data ecosystem, how can we start going a step back and try and say, all right, what are we actually trying to automate here? How do we assign the responsibilities and ownership of the different stages of the data pipeline in specific and repeatable and scalable ways? So this is an example of bringing data into a volume. It was a long-winded way of being like, look at this cool Parquet data that is chilling here in a bucket. All right, so now back to declarative pipelines, right? We mentioned a little bit that once you have the data in as files, it's pretty difficult to have an evolved way of bringing that data into Spark in a distributed way, and then two, supporting batch and streaming workloads all at once. So I had another document I wanted to show for that, but maybe I will. Don't keep my tabs organized enough. Oh, there we go. So we can drop some of the product documentation and things into chat at the end of this. But at the end of the day, we want to simplify these data pipelines. We want to unify batch and streaming. We want to make sure that data is only processed once, especially in append-only pipelines, as well as we automate the change data capture feeds if data needs to be upserted or merged downline. Finally, we want to integrate data quality, data observability, and make sure that, again, anyone can derive and build these pipelines. So again, the open source version of this is now known as Spark Data Pipelines, but the Databricks version is called Lakehouse Declarative Pipelines. So TLDR, it's just a declarative pipeline. You can kind of see what we want to do here. Bring in any data through streams, make it tables, and then generate downstream materialized views. So let's kind of see this in action in terms of kind of something that we want to generate here. So in the 0.1.1 notebook, quick note, don't run this. This is where it gets a little bit weird with notebooks and pipelines. This is going to be a Lakeflow pipeline. So this isn't just a regular notebook where we can just run cell by cell. I'll actually show you an example of what that could look like. But this is going to be a declarative Lakeflow pipeline. You may see DLT thrown around here as well. DLT was an old acronym that we used, but we've updated the name to be Lakeflow pipelines now. All right, so we've actually done these first few things. This is where we just examine our volume and see our raw data sets. So now let's start creating bronze versions of these tables. That is what cells 10, 11, and 12 are going to do here. We can see that we are using SQL Behind the scenes, this will actually trigger Spark SQL. So without even knowing Spark, you can now do distributed computations just using the SQL language. We're going to create a streaming table. We recommend that your initial bronze tables be streaming tables because bronze tables, again, should be a replication of your source. What this means is that that data will typically be processed as appends, right? It's midnight on October 3rd. We got a new API JSON file. Even if it is going to do an upsert downstream, we want to represent it as its own unique file within our bronze ecosystem. So bronze tables will typically be append-only streams. And we can see here that we are selecting from this volume location. I'm telling my table that it is going to be a CSV format. And I also want to drop any columns that, or drop any rows where it doesn't really match the schema. That's what this expect rescue data is going to be. We'll talk a little bit more about the data quality when we get to the silver tables. So essentially what we're doing here, we're replicating the CSV events files into an append-only table called a churn app events. Same thing for the orders data. Note that this is coming in as JSON, again, showing that support for different file types. And finally, the same thing for the users data. We're also reading this in as JSON. Again, don't run this because this is not a regular notebook. We're going to run this as a pipeline. And when we run it as a pipeline, all of these individual table definitions will then be created as an actual DAG, which is pretty cool. So now let's look at our silver tables. For our silver tables, we're defining a new table called churn users. Note this is an append-only table right now. That's why we're creating it as a streaming table. And with this data, what we're going to do is we're going to expect data quality. We want to expect our user ID to actually have a value. If our user ID does not have a value, we're going to drop the row. And we can see where we're actually pulling this data from. We're bringing the data in from churn users bronze, and we're just doing some basic transformations here. So we can see that we're bringing in the ID, we're dropping null IDs, we are hashing our email, we are fixing the data types for creation and last activity, we are cleaning up just the first and last name text strings, and finally, we're fixing the data types of gender, age group, and churn. Again, this is a pretty simplistic example, but you can kind of quickly see how just by using SQL, we can start enforcing as well as cleaning our bronze data. This is only coming from our bronze data. Same thing for churn orders. This will be a silver data quality assured version of our original bronze data. And again, same thing, we have a couple of expectations here for our data quality. If the order ID or user ID is not null, then we keep the row. We fix some of our data types, and now we have a silver representation of our orders data. Finally, we're going to be doing a join or a more advanced kind of transformation here. Note that because this table is going to be a combination of other tables that we've already defined, it's not going to be an append-only streaming table, right? We're not just going to be appending rows or doing kind of some auto basic CDC. We want to actually create a new leaderboard or create a new table here. And in our case, this is the churn features table that I told you we needed for Zachary's section earlier today. So we can see we actually have a pretty complicated query here. We're taking some data from the silver churn orders. We're taking some data from the app events, and then we're joining them up together. And then we're doing some new feature engineering, creating some new features such as days since creation, days since last activity, and days last event. And note that when we run this code with a materialized view, it's not going to, you can force it to recreate the whole view each time, but typically we only want to merge in changes. Anything that came from our downstream tables that changed or was updated or was appended to, if maybe we had a new kind of row for a new user ID, maybe they got a new transaction in, we want to make sure that when we aggregate and bring that in, we don't necessarily have to recreate the entire materialized view each time. Yeah, imagine you had like 100,000 customers, but for your daily active users, you only had like 5,000 daily active users. You don't want to have to drop and recreate your aggregated 100,000 user leaderboard just to get the updates for those 5,000 daily active users, right? So we recommend, again, it can automatic, with the beauty of Spark declarative pipelines, you can actually just put your hands off and it'll just automatically keep track of it for you with auto CDC, which is really cool. So yeah, the materialized views will only update pre-existing rows. And we have one more called churn prediction, which is going to, again, be a transformation. It's going to be our inference table derived from our churn features. And then from there, we create the tables regarding our, for our BI layer as well. So again, my focus for the next like 15 minutes here is just on the ingestion piece and the silver transformation piece and how we can organize all of that with the Lakeflow pipelines. So let's go check out what this is actually going to look like. Again, if you've already run, if you were able to install the demo, then you should be able to go to jobs and pipelines here on the left. And you should see the job, which again fails because of the Gen AI task that we don't have permissions to in free edition. But under the pipeline, you actually see that that should have succeeded, hopefully. And that's what generates all of the tables within our schema. So here's what the pipeline looks like. I just want to take a minute to appreciate. Thank goodness that it actually worked. But I want to take a minute to actually go over the UI here, and then I'll show you how to actually create a pipeline from a pipeline notebook, quote unquote, that utilizes all of these table definitions here. So in our execution, we can see that this was completed. And if I wanted to, we could select individual tables for refresh. And if we actually look at this, what I wanted to show was the auto refresh being like not full, but I'll find that in a sec. I'll update details. There we go. So we can see that when we ran this was the first time that I ran it. So it actually ran as a refresh all. And you can see that if I click the start button, if I click the down arrow next to it, it has two options: full refresh, validate, and then actually start. So by default, the pipeline will only bring in new files and update those updated rows downstream in our materialized views. If I wanted to basically wipe everything clean and re-ingest everything from my cloud storage bucket, I can do that with a full refresh all. Or you can trigger just materialized views to be a full refresh if that's something more up your speed. But let's actually zoom in here. If I close all this out, we can actually see some interesting stats here. So we can see our streaming tables: churn app events, churn orders bronze, and our churn users bronze. These represent the original files coming out of cloud storage and into our table. And we can see it only took like 5 seconds for this to load. I can actually see my expectations and schema here. So this was the parse schema that we discovered from those files. And we can see kind of where this is flowing into as well. And again, we recommend having all of this defined when you create the streaming table, typically in SQL. So we have data flowing in from all three of these tables. We then represent our silver version here. And again, we can see the source code where I defined the table definition, define any expectations, drop if I have a null ID, or drop if I have a null user ID. And same thing for schema as well as for users. Next, we combine all three of these tables into another silver table called a churn features, which has this full schema. And if you look closely, you'll see that it has 68,000. After we did all of our joins and group bys and aggregations, we ended up with 68,000 rows that were here. Note that if we did drop rows for any reason, that would also be listed here. However, I think all my data was clean and beautiful, so I don't think we actually dropped any rows in this example. And then we can see that all of these features then went to our inference table, and we still got 68,000 records, which implies that we were able to make a churn prediction for every single user here. But again, let's think about how this would run on a nightly basis. Every day we get new information, maybe new user transactions, etc. When we schedule this to run every night, we only ingest those new documents, those new files related to those new transactions. We then only update the rows in our feature set for the users with transactions on that day. And then we only make new inferences for those users that were updated yesterday. So we don't have to be recomputing all 68,000 users every single day if only 4,000 of them actually did transactions in the last 24 hours. So and that's kind of the beauty of these pipelines, and it'll automatically kind of figure all of that out for you. We can also see this integration between all these tables using Unity Catalog lineage. If we pop back to our catalog and go into our DB demos tables, let's actually find our churn predictions table. So this is the inference table, right, that we make after we train the model that Zachary created earlier. If I go to lineage up here on the top right, we can actually check out the lineage graph, and I can continue to expand like all of these. And you can quickly see that like, hey, here is all of the locations of everything that came in, even the volume. So let me finish uploading these and then I'll zoom some of these out. Boom, boom, boom. Basically anything with a plus can have like a zoom out. Oh my God. Databricks. Don't be annoying. Boom, boom, boom. Cool. I guess that's good enough. But basically, just by looking at this first table, I can see that the data originated in a volume. We then streamed it in through these streaming tables, combined them into a materialized view, and then created this final prediction table here. Note you can even integrate your Unity Catalog registered and MLflow registered machine learning models here as well. So if we go down, let me see if I want to do the churn prediction. Maybe it's just going to be churn. If I look at, yeah, you can see the column lineage here as well. So if I actually had one of these columns that was derived from a machine learning model, I could look at the column lineage and see that this column came from a prediction from this model, which is again very cool. So again, like this goes back to the questions like Vertex AI and stuff. Like I love Vertex AI as much as the next guy. I don't know if I'm allowed to say that at Databricks, but it's fine. It's a good tool, right? It's good for what it's useful for. But how do I get the models trained there, kind of plugged in with my wider data estate, right? How do I make sure the lineage and governance is in place to be able to see that? Cool. So just to kind of wrap up here, then I have one more thing, and I think we're right on track on time. If I wanted to actually run this, first we need to create it as a pipeline. So to do that, we can go back to our jobs and pipelines over here, and we can create a Lakeflow ETL pipeline. Again, it's recommended to create this pipeline first in that notebook that I was mentioning, either as SQL or PySpark. I recommend SQL. Name the pipeline. I'm just going to call this demo pipeline. A triggered pipeline means it'll run on a batch schedule, but you can see that just by clicking continuous, this will create a full streaming pipeline. So this pipeline would be always on, and it'll always be looking for new files dropped into that volume to then ingest and update your downstream views. Of course, though, you end up paying for that compute, so please just use the compute that you need. Now we attach the notebooks or files that represent the pipeline code. Again, that's why I really want to specify the difference. If you're building a pipeline, a Lakeflow pipeline using SQL and PySpark, you have to run it as a pipeline here. You can't just run it within the notebook. But we can go find our notebook. Again, it should just be this data ingestion 1.1, and I hit select. Now it knows to run this notebook. And then finally, I want to write this out to my DB demos location. And that's it. All I have to do now, actually, I'm going to change this to go to my like default location, I guess, just in case it actually runs. And if I hit save here or create, We'll see that this is actually going to create a new pipeline, and we can even do a validate just to make sure that all these tables will work. This will take a few minutes because it has to go through and quickly do a quick check on the data sources as well as the downstream tables and just make sure that everything kind of looks good. But there's also a way to incorporate some CI/CD into your Lakeflow pipeline deployments, which is pretty nice. If you really wanted to run the pipeline, though, again, you could find the pipeline that we ran earlier, and you can always hit start or full refresh. If I just hit start here, this will actually also execute. Oh, it doesn't like it. This is what I get for, it's probably mad that I have too much going on as well. But you can also just rerun the pipelines here. Long story short, when you define a pipeline, it needs to be defined as a Lakeflow pipeline or a Spark declarative pipeline and not just run as a native notebook. My final note on this, then I'll show my last thing and get out of your hair because I know it's almost lunchtime. I also mentioned that we can declare these these Lakeflow tables as PySpark as well. The 1.2 is a representation. No, just kidding. 1.3 is a representation of building the same DLT pipeline out, but with PySpark. So if you're a technical engineer and you prefer using PySpark versus SQL, you can totally do the same thing using our Spark read stream and then defining at DLT, this is going to be a table, and we're going to expect all of this. By default, it'll know to create this as a streaming table because of our Spark read stream execution here. And again, now we're getting too technical looking at all the Spark code. I totally get you. When I learned Spark, it was like, oh my God. But I wanted to, again, demonstrate that we're doing the same Spark transformations here by hashing the email, fixing my strings, all that jazz. So for some reason, the SQL interface doesn't give you the flexibility you need to create these pipelines, then you can always turn back to the trustworthy PySpark interface as well. One last thing to call out, we'd mentioned expectations and things as well of that nature. These are some queries that we can actually save those expectations off to tables, and you'll actually see that in our catalog. We actually created a DLT events table that got defined when we defined the original pipeline. And you'll see that when a row violates an expectation, instead of just disappearing into the ether, right, we actually log it and we can say, hey, this row did not have a user ID, so we didn't ingest it. And we can save that off to some of these tables down here. And then we also just rigged up a quick dashboard for you to look at for this. We'll see if mine actually loaded or not. Oh yeah, here we go. Retail data quality. There we go. So we can kind of see, oh, this actually worked. Amazing. Good job, Databricks. I love it when a plan comes together. We can see that during our DLT pipeline that ran earlier, it ingested 3.3 million rows. Pretty awesome data at scale. We had a 5% drop rate, I guess, on some of the invalid user IDs. And we can, again, kind of see our flow of failed to pass records. So it's very easy to spin up a dashboard maybe built out of the box just like this, or if you have a custom monitoring dashboard as well. We can also tie this into SQL alerts, PagerDuty, Slack, and Teams notifications. I've seen all sorts of things of how people want to be alerted to when their pipeline breaks or when the pipeline maybe drops more rows than expected, etc. We want to make it really easy to go back and re-ingest or repair different parts of the lake flow. I guess, pun intended. All right, the last thing I have, because I know this has been me babbling. If you want to run some code, the quick demo I want to walk through is the data governance one. So again, this is optional because I know you've been online for like 3 hours. But 0.2.1 we can actually run together as a notebook, which is very fun. Well, let's connect to our serverless. And before we run it, we actually need to create some user groups. So the purpose of this notebook is to define row level and column level access controls. So you may hear this as RBAC and ABAC, right? As well as like PII detection and masking. So depending on different users and user groups, we want to be able to limit who has the ability to query this data. And fun fact, this integrates perfectly well with Genie. When you make a request query to Genie, as Mohan showed, we know who you are. We know what groups you belong to. So when Genie then queries the underlying table, it only brings back the rows that your user permissions have access to, which again is pretty neat. And if you create like a Genie interface for Teams or Slack or Google Workspace, then you need to also make sure maybe that's running on a service principal or something. So let's actually create a couple of dummy groups here. To do this, I'm going to go to my profile up here on the top right, click on settings, and then we can go to identity and access. This is where I created just a couple of default groups. We can manage groups, and yeah, I created them already, but analysts, data engineers, and retail admin. You don't have to add yourself to them or anything, but we can add group, and we can create a new group, and we call like analysts 2 or something. So all that does, it creates a user group. And a common question I get is, does this interface with like Google IAM or Okta or Active Directory? And the answer is yeah, of course. I don't think I've actually seen too many cases where the group definition was actually defined within the Databricks UI, right? You'll typically have some infrastructure, networking, security person who will define all the groups in wherever you define your groups. And we want those then to persist all the way down into Unity Catalog, where we can then start using those responsibilities as custom, I guess, like security protocols. But if you're following along, we do in the UI need to create 3 groups, one for analysts, one for data engineers, and one for retail admin. You don't have to add anybody to them. Once you've done that, you can go back to your notebook, maybe give it a minute to persist, and then we can run all cells. So what is this code doing? Well, you can see that we're adding fine-grained ACLs as well as demonstrating some of the data lineage here. And if I scroll down, I had to make one change. I think I had to add this line, use schema, because I was looking for the tables in the wrong spot. So make sure to add this use schema line if you want to run it. But what we can do here is we can grant specific permissions, such as select or modify to specific tables, depending on group permissions. And then maybe the more exciting stuff is adding in masking rules. So for example, I defined a simple function that utilizes the Databricks SQL function called simple mask. All this does is that it hides the value and returns just a couple of stars here. So here's kind of what we're doing. Alter table, alter column, email, right? Set a mask as simple mask. If my account is retail admin, then bring back the value. Otherwise, bring back a hidden PII masking, right? And we actually automate this now as well with something we call PII detection. Another one is maybe based on country. This is a row filter. So first this was column masking, and now this is row filter. If I'm a retail admin, I can see anything. Otherwise, if I'm not an admin, I can only see US. And again, this can also be more granular depending on your user group. If you have folks in EMEA, maybe they should only be able to see rows where the country is Europe, right? Or the continent's EMEA. Cool. So we can actually see what happens because I did not add myself to any of the groups that I made. When I do a select star on this table now, we'll actually see that the email is masked. The first, last name, and address are masked, and I only see the country being USA. I cannot see rows from other filters. And again, if I was querying this with Genie, I would get the exact same results you see here because Genie knows my user profile and knows the security methods that I have. So yeah, a lot of good announcements around RBAC and ABAC. We actually just announced a lot of ABAC functionality at our Databricks Summit this year. So definitely go and look for that. Otherwise, I'm at 11:59, so I am right on the buzzer. Hopefully this was a really fun workshop for y'all. We'll stick around for maybe 5 minutes after the top of the hour if you have additional questions here. But again, just to recap, some things to take away from you all. Databricks, we want to be that data platform of choice. We want to be that technology to fill your pain points, whether it's on the data engineering whether it's at the distributed computing at scale, whether it's at the governance, organization of machine learning models, AutoML, generative AI, integrating with Gemini and other large language providers, or even just being that interface for your customer or business-facing executive. How do we do text to SQL? How do we do AI intelligence? How can we kind of find those key KPIs and semantic metrics that we know you actually are basing your decisions around? And while Databricks does a lot, it can also do just what you need it to as well. So if this was exciting or you found something interesting out here, then definitely please reach out. Please reach out to your account team or kind of follow up wherever you sign up for this workshop. And I appreciate y'all sticking around. Top favorite 22 participants.
Yeah, so nice job, guys, and thank you to all for attending this. And I hope you enjoyed what you saw. And if you got any questions, certainly please come back to us. Okay, but cheers to all, and thanks.
Let me see. Any limitations to DLT? I would say that like with Lakeflow pipelines and everything, anytime you have a solution that tries to make your life like easier and more efficient, I think you lose some customization and flexibility with it. So if you have some really fancy or really specific customer like business logic that you want to implement into your data transformations, then maybe you may have some workarounds to have to do to get that to fit into your Lakeflow pipelines, right? But if you're just doing pretty straightforward ingestions and transformations with your typical Spark transformations that we see, then Lakeflow pipelines typically accelerate that quickly. Most of my customers, they use a combination of Lakeflow pipelines with, I guess, manually created engineering pipelines. For the easier pipeline, right, just a JSON response from an API. We've all done that a million times. Lakeflow pipelines can really accelerate that to get into a silver level table. But if it's, like I said, a more maybe business use case, specific edge case, then you may want to have, maybe you want more manual intervention into the pipeline. Then you may do that just with regular PySpark code as well. So again, we just want to give you options to be able to create this data estate in whatever optimal way it is for your organization. Great question. I still got a minute or two here if anyone has any other Q&As. Otherwise, definitely feel free to hop off. Yeah, thank you, Jesus. Performance-wise, Databricks on Azure and GCP. Honestly, I don't have too much of an impression. As kind of Juice mentioned, Databricks has parity, at least in terms of performance on all three clouds. Typically for multi-cloud strategies, organizations have like a Databricks workspace in each cloud, and then we can actually do something called Delta sharing. We didn't mention Delta sharing a lot today. Let me actually find it quick. Basically, Delta sharing is a quick way of, let me share my screen real quick again. Boom, boom, boom. I promise we're almost done. Delta sharing is a quick way to basically share any data product within Databricks across Databricks workspaces, regardless of cloud, right? It doesn't replicate it or anything. So let's say you have BigQuery data and you want to connect that with maybe Azure SQL Server data, right? You have two workspaces, one in GCP in the same region as your BigQuery, one in Azure with the same region as your Azure SQL Server. Bring some pipeline in, maybe you ingest some data out of BigQuery, maybe you need some minimal transformations, maybe you want to run it through Gemini hosted on Databricks or whatever. But then you can share that final table back to your Azure workspace. And then in your Azure workspace, you can log in, connect to that BigQuery data set that you just ingested, connect it to your SQL Server data, and then create some final gold level. And if you're even feeling kind of nuts, you can then share that back to an AWS workspace where maybe people are, their Snowflake instance is deployed, or BI layers deployed, and you can query from there. So the other cool thing is that depending on how you've set up your Unity catalog privileges, a lot of those like groups can be replicated across all those clouds. Like I said, if your parent is like Active Directory, you can replicate a lot of those groups into Unity catalog across those regions. So as your users switch between clouds, they have the same governance and RBAC, ABAC capabilities too. But yeah, honestly, performance-wise, it depends where most of your data ecosystem is. If you're doing a lot in Google and you have a lot of your data and a lot of your AI in Google, then definitely a GCP workspace makes a lot more sense than trying to set up the networking and VPCs to get to your Azure workspace just to connect to your Google data resources. So there's a lot of good architectures out there for multi-cloud stuff. And again, like I came from a multi-cloud shop, and that's a lot of my customers, and Google has a soft spot in my heart. All right, what else we got? How are customers using Databricks and use? Yeah, again, like typically it's your data sets live in Azure. They come in through Fabric and Databricks Azure and Synapse and all that good stuff. But our Azure Data Factory, whatever you want. And then they're doing like AI on Vertex AI as well, right in Google. And it's kind of frustrating to be able to make sure that you have a single governance and transparency layer. So in that use case, like I said, typically, you have an Azure Databricks workspace that controls a lot of the transformations, or at least governs a lot of the final data products created in Azure. Delta share those, replicate, it's not a replication, but Delta share those across a GCP. And then you can pull that data out of GCP workspaces into Vertex to do your model training, log that model with MLflow, connect it, serve it through Databricks on GCP. You can even then Delta share the model back over to Azure if you really wanted to. So you go and do all the inferencing on your Azure side, right? So like the churn prediction inference, you can then do that on Azure. BigQuery can be needed. It depends on where you want to use it, right? I would say that like the BigQuery ML side has some limitations. Doing expensive distributed transformations within BigQuery can also be overly expensive. But if your goal is to just use it as a simple OLAP, it works really well as an OLAP solution, right? So again, it depends on like where you want to be consuming products, and just making sure that again, I kind of mentioned that BigQuery thing. Sorry, I'm going way over time. But a very common thing I've seen too is this idea of iceberg. So let's say that your business analyst is really love querying data through BigQuery. You can actually do all the big data transformations within Databricks on GCP, export them or like save them as iceberg format instead of Delta format. And then BigQuery can then natively read and query from Iceberg. So instead of having to replicate these like large terabyte scale data tables into BigQuery just to be read as an OLAP, you can actually have the BigQuery engine read from these open protocol, open format Iceberg files that are then just governed through UC, which is pretty nifty. And again, like sending that back to Vertex and everything too as needed. So like to me, it's like use the right tool for the job, use the best tool that gets you the most cost performance for the job. Databricks solves a lot of pain points for a very low cost point. But again, it also depends on your specific use cases on where is it a collaboration versus where is something not needed, right? All right, I think I'll leave you there. This has been fun. And feel free to reach out and we'll chat later. Thanks all.